Hello and welcome to the People, Place and Nature podcast. Houses, we all live in them, but we can't necessarily afford them. Besides, we probably want a home, not just a house. And a home is a lot more than four walls. It needs to be somewhere you can create memories, with a bit of character, warm in the winter, affordable, or otherwise, it quickly turns from a home into a burden. So houses, homes, or rather architecture is what we're going to be talking about today with the fantastic Will Campion from Offgrid Works. Will and I met in Singapore a few months ago, and we got talking about infrastructure and housing developments and how things could be done very differently to how they're being done now in a much more sustainable and practical way and more affordable way. So in this episode, we're going to talk about the wide range of projects Will has been involved with all around the globe, including some mega projects, some of the ones you've probably seen in the news. Plus, we're going to talk about his company and how he's constructing homes using robots to tackle the housing crisis. And most importantly, we get to check out one of these awesome properties. I really enjoyed recording this episode, and Will and I actually ended up talking for about 7 hours in total as we ended up going to the pub after the episode, so really fantastic day. Fortunately, you don't need to listen to all of that, but I hope you enjoy and find it as thought-provoking as I did. Many thanks. I hope you've enjoyed the episode so far. Here's a quick message from one of our sponsors. Make sustainability a priority throughout the design process with a suite of tools built specifically for landscape architecture and design. Vectorworks gives you the freedom to follow your imagination wherever it may lead. With remarkably flexible software that integrates BIM for landscape and GIS workflows, sketch, model, and document in a single tool with the world's most design-centric BIM solution. Discover Vectorworks' landmark and design without limits. Visit vectorworks.net to learn more.
Yep. Do we have to clap?
We edited that in, didn't we? There's an audience you can't see hidden away. Yeah. You ready? Yeah. Will, absolutely fantastic to see you again. It feels like we only saw each other yesterday, but it's surprisingly been a couple of months already. Yeah. But we met in Singapore on an Innovate UK programme.
Yeah. It's almost as hot as it is now.
Yeah, incredibly warm, incredibly warm. And that was a really interesting sort of programme. So we were both there for quite different reasons, but to talk about sustainability and net zero and how Singapore can look at new technologies, new ideas, and how UK companies can find opportunities there. Yeah. So we were both part of the same programme, coming from the UK to talk to Singapore companies and the government and sort of things going on there. So that's where we met. Mm-hmm. And we sort of clicked right away, really, because what we're doing is quite similar. We're coming at the same sort of problem, but from different perspectives, which is quite interesting, and different disciplines as well. Yeah. So I think finding out a bit more about what you do, what you have done, and what you're doing now would be really, really interesting. Because for me, it covered so many things I had no idea about or didn't understand the sort of depth of ideas and things that were sort of happening in the architecture world.
It's true, yeah. I think that's what's interesting. I think that's why GBIP is really good.
Yeah.
Because I think that was your first one.
That was my second one, so I've been on one to Brazil before. But it was your second one as well, right?
Third one.
Your third one?
Yeah. Oh, wow. So like a veteran of the GBIPs. Well, that's what's amazing about it, is like, you don't really come across that many people in like horizontal industries. So I think that was like really complementary skills and there's a lot of synergy between us. But at the same time, I was literally working on a project being like, I wish I could talk to someone about the stuff that you're doing. Mm-hmm. And then probably vice versa. You're thinking the same. So yeah, definitely hit it off pretty quickly. But yeah, time flies. I felt like that was not that long ago. It's great that we can sit down and discuss, everything that we're working on, and I get to talk about stuff that I'm doing rather than just to people who are getting bored of it. I know. And just rattling
That's what
on.
I always worry. I'm always talking about so many things, and you start thinking, people, they're starting to lose interest in what we're doing. But I think what's really interesting about the GBIP stuff, just talk about it very quickly, because it's a fantastic opportunity for people with innovative ideas. So I've sort of mentioned it already, but it's basically government support for new companies or new ideas or companies that are trying to innovate and do sort of R&D or bring new technologies to new markets to help support them in going to these markets and meeting sort of key people. Yeah. So what you do is you get to meet a lot of really fantastic companies that have sort of been pre-selected by members of the British government who work in these sort of territories or countries. They introduce you. But also, and what I found on both of the programs I've been on, which really surprised me, is the selection of companies that go is fantastic, because we're so, as you say, horizontally aligned in what we do, and there's many other people we met that are as well. And our Brazil trip ended up with us leaving with sort of 2 new partners for projects, which is fantastic. Yeah. and that's something none of us ever really expected to find on the program. So if anyone has got a really innovative idea, has got a business that's looking at new territories, I think we should probably open by saying that's why we're sat here. I think there's going to be another podcast with a company that we met from Mexico on the Brazil one as well, talking about what they're doing with algae and things later on. So anyone that's got really interesting ideas, wants to move to a new territory, start looking at these GBIT programs.
Definitely, yeah. So that's, stands for Global Business Innovation Program by Innovate UK. Yeah, really recommend it. And we're not even sponsored to say that.
Exactly, we're not sponsored. Though I do feel, we're slightly indebted for them helping fund the trips. And things,
exactly.
So,
but it's no requisite to actually like publicly say it. But each one has been kind of better than the last. And never you go in there with one expectation of, I just want to go and learn about South Korea or Taiwan or Singapore and see what they're doing in the market. How can our product fit? And then you end up meeting all these interesting people doing similar stuff. And I think, there's always this classic kind of Paul Graham thing from Y Combinator, where he's saying how you really need those entrepreneurial minds work better together. You need to be in like a community of entrepreneurs. Indeed. And usually it can be quite isolating when you're running your own company and you kind of only you on your own at the top or with that responsibility. And usually in your day-to-day life wouldn't often come across other people doing a similar thing or doing other entrepreneurial things like naturally. So that's actually a really good opportunity to meet people in doing this similar thing. Also going through the same problems that you could talk about, like grant proposals or talking about trying to break into those markets. And what's interesting on that course, there's some on the program was how some people are a bit more advanced, probably going to like seed stage or Series A funding. And you've also got like pre-seed, like startup, really early stage, and you can learn a lot from each other just through that program. And
absolutely. And people's connections and things as well, though, is really key. So, like with you, for instance, some of the projects you're involved in, they're very much the projects that we want to get involved in as a company, and again, vice versa. And we found this before as well, where some of the things that we're doing, especially around on the water side, actually, we didn't realise some of the new innovations and technologies coming forward that are absolutely complementary to what we're doing, but we hadn't really considered. And actually, as part of our holistic solution, they really need to be part of it. So you start meeting companies and you're sort of going, well, actually, together we're so much more powerful and so much more influential, and can offer so much better service and more of an end-to-end solution as well for clients, that actually we should partner. And that's something that I found again a lot, is actually there's a lot of companies that sort of come out these with new partnerships or deals or whatever. And it's a way for a company to really start developing and building, because suddenly you're not on your own. You've got someone else with a really fantastic idea with a similar sort of train of thought about how to tackle a problem, and then you can work with them to sort of build your own business and join forces to. It's true. Everyone's betterment.
I was thinking how I was saying this before, that if I was trying to do a GBIT on your own, like if you said, I'm going to go out and do the exact same stuff that we did, like one, it would probably be impossible to get in the doors that they allow us to, and it would be like you couldn't line up all those people. It helps when you say, I'm here with the British government. It opens the doors to speak to the people you want to speak to. And then I've met so many great people in the different industries, because like what we're doing spans quite a lot. Like I said before, we're kind of vertically integrated architects, so we have a development and construction and design, and a bit of robotics. So it's like you're able to meet loads of different people doing lots of different stuff, and the UK government's able to facilitate that. And I think what was really good about the Singapore one was, say, going to Ecosperity, which was like an invitation only, and you could only get in the door. And I don't know how they got us tickets. But
no, I don't. Especially when the president of Indonesia turned up.
Exactly.
Which wasn't expected.
There's like airplane-style security coming in. And you're like, who's that for? And it's like, president of Indonesia, or like CEO of BlackRock or McKinsey and stuff. And I met some really great people that like had a really good chat with like the head of Breakthrough Energy, who's like the VC for Bill Gates' climate tech fund.
Oh, okay.
And I've been talking to them since, and they're really elusive, like really difficult to get in the door, or just get hold of them or just chat with them. And it's like, you could only, like that would have been impossible without GBIT.
Absolutely. I mean, we had the same thing. I met a gentleman who is responsible for basically energy and water for India.
Right.
And then we met another person on a previous one who's from the World Bank, responsible for more than one continent for the World Bank.
Yeah.
And you think, how on earth did we end up chatting to this guy? A totally, almost random event, But in getting to the events themselves is incredibly challenging. You say a lot of them are invitation only.
Yeah.
But actually, when you are there, because of the program, you're with the decision makers or the key people. So, for instance, in that instance, we were talking to a lady, and she said, "Oh, do you know who you need to talk to?
Yeah.
This guy from the World Bank.
Yeah.
I'll call him. Oh, come over here, have a chat to these guys." And all of a sudden, it's a whole totally different door that you never anticipated to even come near open to you. So really amazing how you connect with these people.
Yeah.
And it's just those small little connections suddenly, because they're such interesting people and so well connected themselves, it just opens so many doors.
Yeah.
Fascinating, really.
You never know who you're going to meet. Because there was even one time we just went to, it was the Asia Tech Week type thing, Expo. And I was like, I wasn't really fancying it, not too sure. But I just went only for an hour, just to look around. I got talking to one guy, took his, just his card. And yeah, we've been talking ever since. And now we may go for the bilateral or something together. And we've actually, that was probably someone we've been talking to the most. And it was just from, going to one thing, you never know what's going to come out of it.
Absolutely.
You think, it's just going to be a trip to Singapore. But yeah, you just meet so many great people. So like yourself, that was it.
Exactly.
We won't be doing this chat otherwise.
Indeed. Well, I suppose that brings us to, who are you? And at last, finally got around to it. And why are you here? So I think you've got a really fascinating background, and some of the projects and things you've been involved in have just been amazing. And I think I'm just not going to do introducing some of the stuff you've done justice. So do you want to talk a bit about your background and the sort of projects you've been involved with?
So I'm an architect by trade, so fully qualified, and then studied in the UK. And then when I was doing my master's at Cambridge in kind of climate resilience, but it was my master's in architecture, but it was just, if you do like a 2-year research project, and mine was on flood resilience and all about climate change and how we can adapt the built environment to prepare for climate change. And I got really interested in flood resilience because like where we are now is Lincolnshire. I was born in Boston, Lincolnshire, the original one, and that's very low sea levels, very low compared to sea level. So it's a huge risk of flooding, and there's not that much kind of being done about it. So I was doing a lot of work like how you could adapt buildings to that, and then got really interested in the flood defences being built in New York, and then basically went and worked for BRK Ingalls Group in New York to help design the flood defences out there. So that was during my research at Cambridge, and they and got really lucky because they had just stopped the project, and just as I joined in that September 2018, they restarted it because they designed something called the Big U, which is all the way around Manhattan, a huge new park, kind of like the High Line, but it's called the Dry Line. So it goes all the way around the edge, and it's a huge flood defence, but it doesn't look like a flood defence. So it's all lots of kind of public engagement stuff and parks and like kind of facilities, and there's an aquarium and a museum, and there's a huge master plan, and that's to protect from rising sea levels, but also hurricanes and storm surges. And then I worked on one of the small U's, because the Big U, which goes around Manhattan, you can imagine Manhattan's kind of like a U, it's split up into lots of smaller U's, which then go deeper into the island, so that when a hurricane hits, like Hurricane Sandy, and you get flooding, you can close these barriers and across like FDR Drive and all those and different avenues, and you can kind of close off all this thing like a ship, and then it becomes protected. So I worked on one of the first one, which is called East Side Coastal Resiliency. It's like a $2 billion project all across the east side near Williamsburg Bridge, and we redesigned this massive park. It used to be called East River Park, and we basically rebuilt it 8 feet high, or like almost 3 meters taller. There's a huge kind of flood defense in it, and there's a load of new little bridges, and it's quite a major project that's under construction now. And I was like featured in, well, the project was featured in the New York Times, and then I was pictured in the back because we did loads of public engagement, and I was getting shouted at by people because everyone was against it, even though it was defense, because a lot of people didn't believe in climate change at the time, and they didn't like how we were having to, you know, remove their park for a few years before we built a new one. And but was eventually kind of won them over with it's pretty cool design. And going back in next month, so I'll finally be able to see it and kind of what they're doing. But that was what really then got me into sustainability, because we was working with all the government officials figuring out how high does sea level really need to be because of climate change, and we're realizing that all of the best estimates from USGS or NASA were saying were almost completely wrong, because sea levels were rising way faster than, like, twice as fast as we thought 5 years ago. So we were having to like keep edging up the flood defense, because it was taking, well, it started in 2012 after Hurricane Sandy, and we're now sort of 10 years later, and it's only being built now, and the flood sea levels are rising way faster than we thought. So we're having to kind of like itch it up, and then you start to realize, oh, we're in a kind of a serious problem with climate change, because even if we're building these flood defenses for Manhattan, which is the richest city in the richest country, we can't even try and defend like some of the richest sort of neighborhoods, and let alone what could have been done with Brooklyn and Queens. You know, we could only focus really on Manhattan, and you start to realize what we're even going to do with the rest of the city. Yeah, a lot of it is about 1 to 2 million people are probably going to be underwater by 2050, and if we don't, you know, reduce carbon emissions, but to net zero, and at the moment we're kind of way off target. Yeah. So there's this huge issue, not just with what we do with climate, but how we adapt the built environment. So we then also worked on another project with the UN to kind of fix that, which is to design floating cities. So we designed with MIT and all the best engineers in the world, how could you build a floating city in case you can't build flood defenses, you have climate refugees. And so we developed that, and it was kind of pretty highly publicized, and now we're building the first prototype in Busan in Korea, so in South Korea. And they're going to build, because they've got a really bad housing crisis anyway, so they're basically building platforms in the sea or in the river. And that is kind of one solution as sea levels go up, and we presented it to the UN, and it's like a whole actual, you know, possible thing. But it kind of it's a bit sad when we realise that we're just going to have to be abandoning the cities. That's the point, is that these platforms will rise, and then the cities that we know now will be abandoned. And if we don't do anything, and you kind of realise, oh, we're in a bit sort of dire straits, when there's about 500 million people in the world at risk of these sea level rise, and currently there's no other solution other than to abandon kind of ship, unless we do something pretty drastic to stop climate change. And yeah, so then I came back to the UK, and with this new kind of found worry, and was starting to think.
You realised how many of our cities are at risk.
Yeah, exactly. I realised, wow, Boston, Lincolnshire's the least of our worries. like New York can't even do anything. Yeah. And yeah, fundamentally, it's got to be a bit like a holistic solution of how we can like reduce greenhouse gas emissions. And I continued to work at the Arc Ingles Group in London, and then we worked on some super sustainable like net zero projects, like at the very cutting edge of like any construction on Earth. So that's like NASA moon base, or well, actually that's not on Earth, but then the or NEOM. So we were worked on most of those projects, and was doing a lot of the net zero cities out there, and they're really pushing the limits.
So these are ones in Saudi Arabia, right?
Yeah. Exactly. So probably see the line is quite popular, but Big didn't do that one in particular. But there's the Oxagon, which is like a net zero industrial city, also floating, half floating, where there's a lot of agriculture, and and they kind of desalinate a lot of the water, create a lot of green hydrogen, and then there's a big port there because it's very close to the Suez Canal, and that's their industrial hub that will feed the line and feed Riyadh. So, and those were really pushing the limit on what you could do with urban agriculture, what you could do with green hydrogen, having like building a city from scratch that's 7 kilometers wide, of like, how would you go about it? What is the best way? What's the most sustainable way? And they're also wanting to move away from oil. So that's the whole reason of NEOM, is they know that if the whole world goes net zero, oil's not going to be that useful anymore. And they're trying to diversify eventually. And they also have this triple win where they're currently using mainly oil, and they're using it at cost. So they're not making any money off of it. So the quicker that they get to net zero by using solar, because they've got a lot of solar, or hydrogen, they can free up the oil to sell everywhere else for a profit. So they've got a massive incentive to get to net zero, well, in the cities as quickly as possible. So they're really advancing in terms of their investment in hydrogen and green hydrogen and solar. And at the moment, when the rest of the world is kind of slowing construction and kind of a bit on the fence about net zero, they're the ones who have the cash to just plow ahead and keep building these cities. And as quickly as we were designing them, they were building them. You know, as soon as you design the layout, there's a guy out there with diggers, and you can see it now with the line.
Yeah,
like if you
carving through the rock.
Yeah, exactly. You think it's ridiculous. It's like 170 kilometers long, 200 meters wide, 500 meters high. There's no way that, if you're trying to say that build that in the UK, it would take centuries. But they're just like, they're out there with diggers already doing it, and they don't even know what it's going to look like. Fundamentally, they just know it's in the line. It's 200 meters long.
Big, yeah.
Just keep going, and they don't mess about, and they've got the cash. They're not having to. They're getting investment, and there's some loans, but fundamentally, they have trillions of dollars just in the bank that they've accrued through decades of supplying 10% of the world's oil supply. And if they can kind of do it first and prove maybe hydrogen works, or fusion, or like floating cities can work, and they're putting the investment in, we can kind of, well, we're doing a lot of big, and we as in like the UK and US and the world is actually all kind of developing these systems. We can learn a lot from their investment.
It's like the test bed, basically.
Yeah, it's like a huge living labs. Like all these cities from scratch. We had free roam to design them with 15-minute cities, or to have fully autonomous vehicles, have VTOLs, so everything's like vertical transport, drone delivery, like all the cutting edge tech, because the regulation is quite loose, so they can make it however you want. So all the stuff that we wish we could try this in London, but obviously they're a bit apprehensive until it's done somewhere else. There, it's a test bed where you can be like, oh, we want to see if we can do vertical takeoff. Yeah. And they would actually fund it or help people do it. And obviously there's no taxes there. There's huge government incentives. So it's getting pretty evolved. And it makes, that construction is still going on where things are slowing down here. So that was really kind of eye-opening experience, designing all of that, and having, because at university you're taught, I'll do some crazy projects now, write your own brief now, because you won't get a chance in practice. You'll just be designing, like a warehouse in or something.
Leeds or something.
Yeah, exactly. Whereas here it's like design a whole city from scratch, and the budget is basically unlimited. And whatever technology you can imagine, you can create it, and then and it will be built within a few years. They've had this 2030 vision, and it's under construction, and they'll get something out there. And the industrial city makes sense because it's actually got a function, and I think that's going to work. They've got visions on loads of stuff all over the place, but I think that one's makes the most financial sense. And I think they're already selling off a lot of the plots, and they're doing multiple stuff, like may have multiple of these floating cities and stuff. So it's really really kind of impressive. And then I learned a lot from that in terms of what cutting edge of what is possible with construction, and also trying to think how we could try and use that methodology or to solve our own problems here. And yeah, so at Big, it was really the place where people would come to us to solve these massive issues of diversifying from oil or from building a moon base, building floating cities. But no one was really coming to us saying, like, because we were paid as a service. It wasn't like we did it on our own. It's startups coming to us. And then I was thinking, from my perspective, and here it's like everyone's talking about the housing crisis, and everyone's talking about construction productivity flatlining, and how can we build houses cheaper and make them net zero, and all sort of stuff. And no one was kind of coming to us asking, like, how would we do that? It was always, how do we build a moon base or something, or how do we build huge cities in the desert? Where it's like, no one was tackling some of the smaller scale stuff here, which is like probably the less like big crazy stuff.
Yeah.
And it's like, we might as well get the basics right. So that's when I founded Offgrid Works, as in a way that we could build affordable off-grid type housing at scale, and then took the same methodology and everything I'd learned from building at this colossal scale and working with all these world-leading experts in every single field, and the network that I gained from it, to put that into a solution for designing, fixing the whole housing crisis and building houses cheaper. So that was also coming off of the back of me simultaneously doing some freelancing in like housing. So I was building houses like the one at the back, and there's one to the side, there's 3 on this site, and then others in the area. I was kind of learning a lot about just building on that small scale and how we could apply this massive holistic scale thinking of like global level thinking that we did at Bjarke Ingels Group to the kind of the small scale stuff. So yeah, that was a kind of a relatively brief summary of how we get to me then starting the company and inventing this solution to make housing cheaper and quicker to build and sustainable, and then how we can now in that process of bringing that technology to market. And whereas before we were always just developing these technologies like as mercenaries for it was just guns for hire for startups who would come, and like the floating cities was funded by Oceanics and then like a floating city startup, and it, or like Icon with a 3D printing, they would always come to us and say, how do you make 3D printed housing work? How do you make floating cities work? And then we'd figure it out, and they would take our idea and then turn it into $1 billion company, where I just cut out the middleman and was like, oh, why can't we just do that for ourselves?
Why can't I do that?
Yeah, exactly.
Yeah, absolutely.
But it was a weird thing as an architect. You didn't have the business acumen to think. You didn't think like that because we were just pure designers and problem solvers. And no one was thinking, oh, what if we just do it ourselves? So I did an MBA on this as well, through Quantic, who were really good. And at the time I got a scholarship for that. And then I realized, I had no money, but you could go through these ways of developing the business model, getting funding through grant funding, especially if it's super innovative and if it's for the public benefit, then you can get the support and the loans and or in the investment necessary. And you realize that you can bring these ideas to real world. So that was when I was like, okay, I'm going to take a risk and do it, rather than you can get caught up, and it is kind of hard to leave the industry when it changes so much, and you can be like, designing a moon base this few months, and then a floating city the next few months, and then another city, and you're constantly being flown out business class by like the Saudis to meet in the palaces, and you feel like you're treated like a god or something walking around. And then you give it up to be like, I just want to try and make these other things work instead. So you do get drawn into it. But the opportunity cost, I realized, was much bigger to not do this and have the trying to solve the housing crisis and the climate crisis, because yeah, this is going to go on forever. But yeah,
Well, yeah. I mean, my experience is fairly similar without all the grandeur, but
Right, yeah.
but it's difficult, isn't it? Because you end up with lots and lots of projects. You know, like my company, we started 4 years ago. We've done 120 projects now, like from
Wow.
varying scale, from single houses to a driveway to, you know, we've just finished designing the first completely water neutral development
Oh,
we think in the world for 800 homes. You know,
Yeah, yeah.
like really quite interesting stuff. But the trouble is you get these projects come through and you think, oh, that's really cool, I'll just see that through. And then you kind of end up stuck, like just kind of doing the next thing and the next thing.
yeah,
Not that that's a bad thing, but I think we're fairly similar in the sense that there are these bigger issues and you want to have as big an impact as you can on tackling these challenges.
Yeah.
So you kind of have to get to a point where you think, actually, you know, is this something I want to do forever? Yes or no, or maybe, but maybe it's actually that with something else. And then how do you tie those things together and bring the
Yeah.
various ideas and solutions you have together to try and come up with something more innovative and something where you can support yourself doing the range of things that you want to do and do it in a mutually supportive manner.
yeah.
And that's the real sort of challenge, I think.
It's true, because I think the weird thing is it's this call to arms kind of with the impetus of, especially with sustainability, and then working on those big global scale projects where we're like, how do we even fix this? And you realise the challenge that we're up against,
Yeah.
and also the consequences of if we do nothing. I was kind of in that position. I always say it reminds me of like when in Harry Potter and the Prisoner of Azkaban at the end, where he's like thinking, he thinks it's his dad who's the one who casts the Patronus basically, and he's kind of looking around, waiting for it, and then realises it's himself. It was kind of that weird moment where I was in the industry working at the highest levels with all the governments, and then you kind of think, waiting around like, what? Nobody's doing anything.
Yeah,
You-
absolutely.
You're
yeah.
kind of like, oh, we sat here. Everyone's talking about we've got to hit net zero targets, and like 40% of emissions are building, 20% is embodied. And even when we've been on these GBIPs, talk to people about how we're going to tackle embodied energy, and that's 10% of global emissions. Nobody has a clue.
Absolutely, yeah.
And then even when I was in the industry, and we talked to people, there was nobody. There was no. We worked with all the best entrepreneurs. Worked with like Elon Musk or Jeff Bezos, Larry Page, all these guys, and it's like nobody. There's no one actually tackling this fundamental issue. And then I kind of thought, oh well, maybe I'll have a go.
Well, yeah, completely agree with you. I think this is kind of my observation as well, and partly why I decided to go out on my own, because I was looking at these problems and, you know, I wasn't at the same level, but I ended up representing the UK on the World and European Council for Landscape. So I was meeting a lot of big urban designers and seeing all these large landscape projects and meeting lots of architects and sort of looking at them and going, individually the things are great, but like holistically it just doesn't work.
Yeah.
And like a lot of the work we're doing now on water, which is why I was on the GBIT, you know, there's loads of new technologies coming, great, but the technology itself is not the solution. It's part of a much wider solution that actually creates like a sustainable system. And without that sustainable system, you're just, you know, putting a plaster on the wound. You know, you're not actually healing it or dealing with any major problem. It's still not sort of joined up enough. It's all kind of half-assed in a way, you know, or people don't have that sort of forethought that actually, yes, this is great, but actually we need to be thinking beyond that, and how does that then tie into what sits next to it, and then how does that tie into the next thing? And you can easily get sort of overwhelmed, and I think that's part of the problem, especially when it comes to the climate. You know, I've loosely started writing a book called Ignoring the Climate Crisis, because it's a massive crisis, but people can't grasp it. And even at high level, I've spoken to many people at senior sort of levels where they just don't seem to get it. And they're sort of still going, yeah, as you said, there'll be a technology that solves it. We don't need to worry about this policy or whatever. And it's like, if we don't even have the policy basis correct, we're stuffed, you know, we've got to sort of think differently. And as you said earlier, actually really well, sort of the lateral connections are really key. And I think in a way, the lateral connections are more important because you build a much stronger base than if you just go vertically. And that kind of is where I've seen that my observation has been in a lot of the failings. So that's partly why I started to, you know, do more stuff.
It's true, because there's those
myself.
fundamental things, like even say with the housing crisis, even if we said, oh, let's just build a load more homes, and even if we had the technology, like I said, we'd come up against the problem we don't have enough water to theoretically even sustain them. And there's a whole issue anyway, like 8 billion people, maybe 10 billion in the world by 2050. We're currently using 2.5 Earths worth of resources. When there's 10 billion people, we're going to be using even more. So there's not even, we can't physically be doing things in the same way. And there's certain issues that will probably come up that we're not even aware of. Like if like water's becoming a much bigger issue now.
Yeah, well, it might be worth just giving a couple of examples. So we were talking earlier, so the water one's quite a key one. So especially when it comes to things like hydrogen.
Yeah.
So for instance, the UK's hydrogen strategy is based along the Thames,
Yeah.
which is an area under extreme water stress. So we can't really abstract water from the Thames because there's already a lack of water available in the area. And we need that for a lot of industry and things as well. So there's a big water availability issue. Then there's the energy that's required, and we have an energy issue. There's just not enough energy, and the grid can't take more draw.
Yeah.
So that's a really big problem. So actually, is hydrogen really viable in that location? Probably not. It's probably more viable in Saudi Arabia, where they can introduce more renewable energy closer to where they'll be needing it, and then also desalinate water and export it more effectively. Yeah. So that's not to knock us having that industry, but it's just quite a big flaw in having the industry. And then hydrogen anyway, we're talking about having it in the mix, but we basically have to replace the entire gas grid. So, and then you look at electric cars. There's another example of this is a good example of a technology being hailed as a major solution.
Yeah.
And I was at an urban design event recently, and they were saying, how do we design cities for electric cars? And I was saying, we don't want to design cities for electric cars. We want to design cities for no cars.
Yeah,
that's where the ambition has to be. You're just replacing a technology that's causing loads of problems with a newer technology which does exactly the same thing.
Yeah.
And to get the the minerals and things, I think it's something ridiculous like, I can't remember the exact number, but let's say 100 of more of the world's biggest mine, which we currently don't. We've got one major mega mine. There's 100 more of those globally, just to get the resources we need. So it's actually not viable. So, and that's not to say there isn't this major problem that has to be solved, but it just kind of demonstrates that thinking isn't the thinking we need to actually solve the problem.
Yeah. It's definitely it's like just like you said, a plaster. Because even electric vehicles or like cars aren't actually that polluting in general in comparison. They're like 1% of global emissions or something, not even that, in comparison to something like planes. Or they're not even that. Even planes, the aviation industry is only 2.5%.
Did you know the current hydrogen produced, which is because most of the hydrogen is not green hydrogen, it's grey or blue hydrogen. Yeah. The current emissions used in producing that is more than the entire global aviation industry.
Oh, really?
Yeah.
Wow.
So
what they're solving. So even if you had hydrogen-powered planes right now,
it's still incredibly demanding.
The same thing.
And I mean, one of the guys on the trip I can't remember their name. One of the guys who was on the GBIP, they designed a new hydrogen boiler, and they sourced all the hydrogen they could in the UK, and they could only run it for something like 6 minutes. Was it?
Oh, really?
They could run.
I didn't hear what he said.
Yeah, maybe it's 6 hours, but even so, that's all the hydrogen they could source. So again, not to knock it because it's a new industry, and it's definitely an industry we need because it's great for shipping and HGV and all of that kind of thing,
and stuff.
Yeah, big boilers and generators and stuff. But there are fundamental flaws at the moment in the thinking, perhaps, of how to sort of move it ahead.
Yeah, because even just the storage of it, even if you said, okay, we could get hydrogen planes, you can't. You'd have to get it within the fuselage of the physical thing. You've got to compress it so much. You've got to keep it at a temperature.
God forbid there's an accident.
Yeah, exactly. You basically got a flying hydrogen bomb or something going around. Same with any of the fuel tankers and stuff. I mean, electric is one way with that. One option is like methanol, which is another thing that Aramco was really pushing. Interestingly, was they were putting a lot of money into developing methanol so that they could, as byproducts from some of their hydrogen plants you can get. So they would, but also you can just get it from digesters or from, all the waste if you got it from farming and all those aspects. But it's all about circular economy type things. Like I think we've been in a linear economy, and actually things have changed so rapidly in probably 20 years. I remember when I was growing up, recycling wasn't even really a thing. You didn't have multiple wheelie bins and stuff. It was just like, you was trying to get people to even put it in the bin. It was a challenge. Littering was, and now recycling is pretty widespread and pretty robust, but that's still a step away from like full circular economy.
Yeah, indeed.
And we see that I worked on the Amazon headquarters in Berlin, which was the new tallest tower there, and we worked with a company called Concula out in Berlin, and they're trying to fix the problem a bit in the construction, because you sometimes you might demolish a building, and a lot of it maybe goes into landfill because you can't find uses for all of it. But they're actually would go in and assess all the stuff that's going to get binned, and it goes onto a marketplace. And then you as an architect can go in and say, oh, I want to use these chairs or these like wall panels that are coming available, and you know when it's coming available, and then they can strip that out and come to you. So they're kind of linking that up. So it's kind of a circular, but that's a kind of a brand new thing. In most of the industry isn't as sophisticated. You probably just,
indeed,
like you said, you can try and link. When I was doing the cities holistically, you design it from scratch. You can connect everything up quite nicely in like a closed loop. But then when we look at adapting existing cities, like I said, trying to put hydrogen in the Thames, you might think, oh, that's good because we've got loads of fresh water or something there. But then it's going to either decimate the Thames or the hydrogen's not enough. And then when you look further downstream, you realise, oh, what we're going to use all that hydrogen for, it's not that useful. And then you've kind of committed yourself, and then you start to think, oh, maybe we should have just put all that money into solar or something. And it's weird because the people making the decisions, like top level government, maybe they're fundamentally just trying to get re-elected, and maybe their cycles can only be in a few years, and you need kind of like a huge long-term vision. If we're going to say like 2050 goals, you got to be. It's at the moment that seems so far away.
Yeah.
That you're like, oh, we'll wait till the government that's in power in 2046, and then they'll have to be the ones who are to deal with it. Whereas at that point, sea levels will be 1 meter or 2 meters higher than they are now.
Well, I was going to say, what basis? I was going to ask you this later, but what is the basis what was the level you were looking at for sea level rise? What were you trying to accommodate? Just to go back to that other point earlier.
So in New York, it was getting worst case scenario by 2050. It's like 1 to 2 meters potential sea level rise, which it doesn't sound too bad, but their problem is the hurricanes. So as increased sea levels rise, and a lot of the sea level rise is due to water temperature increase, because a lot of the models were based on deep water flows and recycling of the water, but actually they're finding it was quite trunched in layers, and the water at the top was getting hotter quicker than at the bottom, which meant it was expanding more, which means you get a huge, that's what was causing a lot of sea level rise increase. And then when you get deeper, hotter water, you get a lot more hurricanes. So that's why we're starting to see a lot more storms in the Gulf. That's why like California was hit by like a hurricane for the first time in a long time. You see it all the time in Miami. And Hurricane Sandy in 2012, that was the thing that kicked off Rebuild by Design, and $50 billion of damage, and they had to shut down the stock exchange, and it was like catastrophic, like 100 dead. And that was mainly, that was a superstorm, wasn't even a hurricane. But as the sea levels get worse, then you're more likely to see the hurricanes.
So is a superstorm not as bad as a hurricane then?
Yeah.
That sounds like they've worded that the wrong way around.
Yeah, exactly. I think that maybe there's a normal storm where you could be like, oh, it could be in the UK. And then I think a superstorm is just below a category 1 hurricane. So a superstorm's still very, very bad, but a hurricane is like really, really way worse. And you can, so the winds weren't even that bad, but it also means the pressure difference is worse, and then you get storm surges. So as the hurricane goes up, it
drives all the sea sort of in front of it, doesn't it?
Yeah, and it creates even higher sea level rise. So the sea level itself is bad, but if you get a storm surge on top of the sea level rise, you're going to get like catastrophic flooding like all over. And there's other issues of, you might not get, they're all high rise, so you're not really going to be affected in your apartment, but all the sewage and stuff like that is flowing into the Hudson, and once you increase the pressure, the sewage starts coming back up the pipes out into your living room or into your toilets and then into your living room, which isn't very good if you paid several hundreds of millions for your flat. And then so the reason why this sounds like, it's just worst case scenario, but the Hudson itself has a very deep trench in it, and that's what draws the hurricanes. They go up the east coast. If they keep going, they'll always be drawn up the Hudson Trench. So New York is particularly vulnerable if sea levels rise and get warmer, and they keep going up there. So one thing is sea levels rising just naturally as water temperature increases, but there's these other trigger events which would happen anyway. So if we get to a 2 degrees increase in temperature, they predict that will break off the West Antarctic ice shelf. So at the moment, it's not supported by land. It's just kind of sat on the water, and the hot water keeps tunneling underneath. And at any point, that huge shelf could just snap off, go into the water and just kind of melt. And it's colossal. And even that itself could create like half to a meter's worth of sea level increase. And it's pretty catastrophic.
We have a podcast with Jonathan Porritt, who used to be an advisor to the government on sustainability and climate. And we have a sort of segment where we talk to him about sea level rise.
Oh, yeah.
And he sort of, because it was on his book, we talked about his new book as well. And we were talking about that, and it's truly terrifying the extent of potential sea level rise. I think it's 60 metres is the potential far extent of it. But they reckon that by sort of 2300.
Yeah.
But that's really not that far away, when you're thinking, oh well, it's only a few generations, isn't it?
Yeah,
and it's 3 generations.
And as an urban planner, well, just to look at most cities are all on watercourses that have existed. Usually, anything beyond, well, pretty much every single city is on a watercourse of some sort for trade, or on the sea. So a lot of our population is under there. So you're like, 60 meters, you could maybe go hike up a mountain.
Yeah.
It's like, what about all of our civilization? It's like, that is truly kind of apocalyptic. And you could do something about it. That's the thing. If we can, even if we got to net zero right now, we might be able to stop that 2 degrees increase in temperature rise. And whether it's maybe naturally the Earth will eventually warm over thousands of years, but what we could do right now is at least stop that acceleration, and it would buy us time. Even by 2300, we could build new cities further inland if we kind of knew that was happening. And the other flip side of net zero, which is technically our mission statement, is more about accelerating the age of abundance. So what people don't ultimately realize is if we can get to full net zero sustainability, you would get to a point where energy is so cheap that everything just becomes so negligibly expensive.
Yeah.
Because if you could pretty much power the whole Earth on renewables, you don't have to pay for it if it all comes from the sun. Theoretically, if basically everything's in solar, and once you've built the infrastructure for solar and wind and tidal, it's just always going to be there. Yeah. And even once you built fusion reactors, so at that point, electricity would become super cheap. I was talking to a guy from Octopus Energy, and he was saying how even their offshore wind, it's maybe about 3 to 5 pence per kilowatt. That's how much it costs them to build the turbine, and they can currently sell it at the grid rate, whatever it's 30, and they're making huge markups because gas is so expensive, oil is so expensive, and that's how much the gas and the oil companies have to sell at to make money. But the wind and the solar is so insanely cheap.
Well, this is it, and this is why policy is so important. I saw today, actually this morning on the news, that there's been a new round for bidding for offshore wind.
Right, yeah.
And not one company's bid for the new contracts to build new offshore wind, because the government has tried to squeeze it as much as they can. But they've just granted 100 more oil drilling licenses. Yeah. So it does make you think, what's really going on? But also the interesting thing is kind of that there is no one solution either. So for instance, Singapore, again going back to the Singapore trip, that was really interesting because Singapore basically have had to hedge their bets on hydrogen. Now they don't have the water for hydrogen because they've already got a big water problem, which is why we were there. But basically they want to sort of bring in, they want to sort of bring in hydrogen and sort of trade it on, I think was kind of, as I sort of understood it. Right. But the reason they're looking at hydrogen to sort of power the city as well is because they're on the equator, and that means they have no wind, basically. So wind generation just doesn't really work in Singapore. Okay. Also, they have a problem where it's very, very cloudy a lot of the time. So actually they can't use solar either.
Yeah.
So they don't have wind, and their days are slightly shorter, I think, as well. So they have, is it shorter or longer on the equator? I can't remember anyway, but for whatever reason.
Same, isn't it? But it's shorter and
Yeah, they can't use solar. So basically wind and solar is out, which basically, and they don't have any geothermal potential either. Or they have very, very limited geothermal potential.
Yeah.
So basically their only real option for renewables is hydrogen. And also they're one of the biggest shipping hubs in the world, so they want to convert the ships to hydrogen too. So,
and you can't use tidal because of the ships.
yeah, but you can't use tidal because it's on the equator.
Oh right, yeah, because there's less movement.
Yeah. So
they're
so
a bit
basically
stuck.
they're kind of stuck.
Yeah.
So they're kind of investing all their net zero energy,
Yeah.
not as in actual energy, but government energy, people
manpower.
energy, manpower into hydrogen. But there it makes a lot of sense.
Yeah.
But they're looking to use desalination, and they're building the refineries, energy recovery plants and stuff like that, and that waste energy will be used to then produce hydrogen and stuff.
Yeah.
So they're kind of looking at it in an alternative way.
But how do they power the hydrogen?
Through the waste to energy plant.
Ah, okay, right.
Yeah, that's what one of the guys on the trip was looking at, I think.
True.
With
But then they have to
gasifiers and
capture
stuff.
the CO2 from the
Yes.
waste to energy.
Yeah, indeed. Yeah. So nothing's that straightforward. But they've kind of got a
complicated.
different sort of range of problems. But they're really motivated because they're already at sea level, basically.
Yeah.
So
It's
they
right up against them.
yeah. So they also kind of want to be a test bed to help sort of innovate and drive this stuff forward.
True. I think in some cases it's sort of, as a city state, they have the power to look at it holistically and be like, okay, we can do everything just for us specifically. Probably, they're not that big. You could theoretically build up flood defences if required. It's harder when you have a whole country, like the whole of, if it was Japan or something. But Singapore, I think what would be interesting for them is probably by the time they've done it, someone would have cracked fusion to an extent that they would probably be okay. It's an interesting one. But for a lot of other people, there's you got to do something. If you can do something, you might as well. For them, they're in a very unique position where they can't really do. There's not that much. But a lot of places, even say like with Saudi, where they don't have much water, there's a bit of wind, but they do have a lot of solar. So there's usually one or another. You can kind of balance it. So I think that was one of the things that we were advocating for as well. Like if you could link up a lot of the grids anyway. So maybe at some point, Singapore could just buy their electricity from Malaysia or
they're planning that sort of East Asia, Asia Pacific energy grid, aren't they? But that's partly what Singapore is leading on. They're laying all these pipelines throughout the region. But
that makes sense.
But I think what people don't realise as well is the amount of energy that's required for all the different processes, because you've got to have the energy to desalinate, but then you've also got to have the energy to then power the electrolysis of the actual production of the hydrogen. So, and those energy demands are enormous. So,
I sometimes question, what the actual output really is. It's almost one for one the amount of energy currently that you're putting in, especially if it's obviously coming from dirty industries. But if you could have like solar.
That's why hydrogen's so bad at the moment in terms of like polluting to get it. So, which really raises the question of it's got to be somewhere where either you have like nuclear energy, as you said, where they're building new nuclear reactors once they crack it. So that's another 20 years before that comes in. But places, like Morocco, I think Morocco's looking to do something at it. Saudi. There's another country that's looking at it massively. In I think it's West Africa. There's a West African country that wants to become the leader in hydrogen, and they've just invested massively into it. I can't think where it is. But also obviously there's then the challenge of you've got to ship all the hydrogen everywhere. But compared to big electrical grids, I think they lose 10% of energy through transmission. So there's also kind of like weighing that up in terms of how do some of these super grids work? Because there was the big European one planned, which had energy from Morocco being piped into Spain, but the cost and loss of transmission energy through the cable network is so great that it becomes not economically viable, or something I was reading the other day. So there are still quite a lot of big challenges with actually connecting stuff up.
That's interestingly why the other angle of Offgrid Works, kind of, because the nature of why it's called Offgrid Works is saying if we could have more decentralized energy production anyway, and even in terms of like water and electricity and heat, and then food as well. So we're putting all those systems into the buildings and all the developments, so that you don't have to be drawing from the grid, and you don't have all these problems of huge lossy cables and building all the pylons and having to ship it all around. That is probably the only solution that we could do right now as an architect, to be like, if we're designing these new cities, it's a lot easier that they're all self-sufficient buildings in themselves.
Well, I think that's the key, and that comes back to what we're doing as well, because we're doing that with like the water grid, but also looking at it on the energy side, because if you don't have to have, so we use water as an example because it's what we're doing at the moment. Yeah. But if you don't have to connect into the sewerage system, one, you're not putting any stress on all these water companies that are already releasing loads of sewage into the network, and two, you're saving cost then on the cost of the development, and saving money for the homeowners because they're not having to use as much water. And energy is exactly the same. We know the energy grid is at capacity, basically, not in terms of, this goes back to that energy point I was making earlier. It's not just about the availability of energy, it's about getting the energy to where it needs to go, because the grid can't take any more charge through its system, basically, in a lot of areas. So actually it has to be off grid, otherwise you have to upgrade the grid. So, and the same with gas, with hydrogen. To put hydrogen through the gas grid, you have to upgrade the gas grid because the molecules are so fueled that they will escape through the fixings. So all the fixings of the gas grid have to be replaced, which is a massive infrastructure task. So again, how viable is it? So really, these new developments have to be off grid, exactly as you say, for all of these things to be truly sustainable and save money, not just in the installation stage, but the longer term ongoing costs for homeowners.
Yeah, exactly. Because it's a double win even on our side, because then it's like, you get a house. You can imagine if you could buy a house where all of the needs were met and you didn't have to pay utility bills. Even you could theoretically sell excess energy that you're producing back to the grid or to your neighbour who wants to use more of it, who's trying to charge a Tesla or something. And then your house becomes more of an asset where you're not just paying out a mortgage every week, or you can actually be covering the mortgage costs with the energy that you're producing. You don't have to worry about an apocalyptic scenario where there's no electricity or not enough water to go around. You don't have to worry about hose pipe bans. You've got enough rainwater, and then on the other side you can even produce food once you've got excess energy. And you can grow food inside. You've got enough water supply, and you can get even that cheaper. So I mean, our eventual mission as well is that if you could live that, then you'd almost, all of your basic needs would theoretically be met by your house. It doesn't have to be, okay, I've got to get my house and I've got to pay electricity that we've just seen going through the roof, and then you've got all this. And just to survive as a human being is super expensive, which is kind of a bit, against just nature in general. They just have to pay so much money to survive. Well, actually, off-grid construction and design will kind of be quite liberating. That as once you've got the house and that house is producing enough energy to cover almost your mortgage repayments, then you can, you'd be pretty sound.
Yeah, absolutely.
And that's not that far away. That's the funny thing. That's what annoyed me a bit in practice. It's like the technology exists now. Yeah. And solar is becoming so cheap and so efficient, and the batteries are becoming better, and stuff like rainwater harvesters and air source heat pumps and MVHR is getting so much better that you could do it. It's just, in general, a lot of the developers, they don't have to because the policy's not there yet. So you're not forced to have to pay this little bit extra. But it's currently not costing that much more. Like the house behind doesn't cost that much more than a normal house, but it's almost net zero. And the one that we're doing next door is almost off grid, and probably in a few years' time there'll almost be no cost difference, because instead of putting a boiler in and paying for oil, that would be a lot more expensive, you can have huge amounts of solar. So
absolutely.
And then when you get to that kind of world where you can scale that up to even a city size thing, then kind of going back to your point before, what's going to happen is we'll eventually get to a no-car world. That is fundamental, like, change of things. When we get robo-taxis and full self-driving, you'll just have a gig economy type thing where you could park your car and then the car can go do taxiing, and you don't have to worry about it.
Surprisingly, they do it a lot in Russia.
Really?
Yeah, it really surprised me when I was in St. Petersburg last. They're like Zipcar or something, and you see one there. You just open the app, scan the car, hop in it, off you go.
Yeah.
And
it's true. So you can get that now in London, but the point being that the car wouldn't be parked anymore. Even if you have cars, the cars can constantly go around. They can be making you money anyway. They'll be going off picking people up. They could just be robo-taxis, just as you buy them. And that will basically mean you'll have all these car parks sat underneath all these buildings in London and everywhere that are just empty and useless. And they're too small, like too low down to be converted into flats, and they're underground, so they're a bit annoying. But we're kind of saying that eventually you could convert that to urban agriculture. They're perfect for farming. Once we've got huge amounts of clean energy, they can power the LED systems that grow the plants and the pump system. And aeroponics means you don't need that much water. And we'll convert that to food. And then once you've kind of got enough solar and got enough wind, you could almost make cities very kind of self-sustaining.
Yeah, absolutely.
And then you can massively reduce the costs of living, basically. There will be no utilities. The costs of food will be next to nothing because it's just growing everywhere.
And you're de-risking it as well.
Yeah.
Because you haven't got the risk of drought or whatever else it may be.
You don't have to use fertilizers, it's all organic.
Yeah.
You don't have to use pesticides. Crops a lot quicker, you have perfect conditions all the time. But it also frees up so much land for like ecological restoration. I think it's something like if you took the footprint of the average supermarket and turned it into aquaponics or hydroponics or aeroponics or wormoponics or whatever it may be, that is equivalent to about 700 acres of agricultural land. Yeah, I bet. It's true, because that was my final project for undergrad, and that's where it was in the Reba exhibition, and that was for a vertical farm, and I did all the research. And then that was funny, I was supposed to go to MIT to study urban agriculture, because that was like the big new thing, but I went to do Cambridge instead. But that is like going to be a massive field. We see the technology that is available, but weirdly, as it had to be a holistic thing, because there's all this urban agriculture potential. But when we was developing cities, you have to know, can we put it in there where you're going to put it? You got to know, can we free up these car parks to put all this technology in, and is that technology? But at the same time, we need to get the energy from somewhere because it's super high energy. But it's all going to eventually fit into place. Once we're in a renewable energy world, and it's going to have huge amounts of energy in abundance, we can then start kind of growing all these things, and then, like I said, free up the all that farmland for regenerative farming or for growing trees, basically. And so the farmers won't be out of the job; they'll just be turned into foresters.
It becomes a very different use. Like the green belt, for instance. Like the green belt is a great policy for protecting and stopping the coalescence of cities and recycling of land. But largely, green belt was useless because the land isn't used for anything. So actually, if you can start taking that land out around cities and saying, right, okay, we're going to move your food production into the city. Your land use is now changing. That becomes ecotourism or ecological restoration or whatever else. So you're building more sort of community assets. You're replacing that food production with a community asset. So you're building a more resilient community, but then that also can help protect the city from flooding and urban heat island effect, all of those kind of things. So it's thinking about it from that perspective as well.
Absorbing CO2.
Yeah, exactly. Reducing carbon, sucking that carbon back up.
Yeah, exactly. So I'm pretty optimistic that we will eventually find a way. Like, a lot of it is kind of coming towards it.
Yeah.
But I think there was a couple of critical industries about because energy is relatively could be dealt with, and that was something that they talked about in Singapore. Is that say 40% of buildings. 40% of global emissions are from buildings. 29%, 29% is from operational energy, which, like I was saying, you could deal with hydrogen or solar, wind. And then the problem is the embodied energy. So that's the stuff that we're also tackling, because that's 11% of emissions. So it's of global emissions. So it's like 4 times worse than the airline industry. and a lot of that all comes from concrete, for instance, and that in itself is like 7% of global emissions, and we're like addicted to concrete, and it's the second biggest resource after water that is being used, and a lot of policies don't account for it. So when I was on the other GBITs, like South Korea, they'd never even heard of embodied energy. You know, they talk about what their net zero policy was, or they were developing these net zero homes, but they're all built from concrete. And it's like, well, it's obviously not net zero by our standards.
Yeah.
And then Taiwan was the same. And a lot of those policies, they say, oh, we'll be net zero by 2050, but they haven't accounted for that bit. And then, that's a very tricky thing to get rid of, because even the nature of creating concrete, you have to break down the limestone from calcium carbonate into just the calcium powder, and you release the carbonate bit
through that process. Yeah.
So you release the carbon dioxide through that process, and then you do absorb a little bit going back through it, but not all of it, and that's like 50% of the amount. So even if you could deal with the energy side, you still just the nature of creating concrete release it, and you've got to kind of, that is kind of on the heads of architects in a way. And weirdly, when I'm always looking at it, you can kind of get to net zero concrete, but it's going to be more expensive, which means that all construction, just the buildings, become more expensive. Or I think that's where a lot of the effort's going into, like I was saying. But nobody's really thinking about it kind of holistically, as in like, why are we putting all our effort to try and create net zero concrete when 90% of concrete could just have been done in timber instead?
Yeah, indeed.
And then most people don't realise that. They think, timber is more expensive now, but as concrete gets more expensive through the turning it to net zero, then it's going to it means that timber would be cheaper.
Mm-hmm.
So I feel like, you really need to, everybody kind of looks at it from a massive...
This is the trouble, though. We need to kind of take
angle.
a step back and go, right, where do we want to end up, and how do we get there? Because it's kind of like looking at all of these things we look at everything in a weird way. We kind of look at stuff in too much detail in some respects, because then you miss the bigger picture. And as you say, we'll solve this problem, but then you're not tackling with that other bit that sort of sits next to it here. It's a funny old world. Yeah,
because it's an interesting consequence of just the modern world in general. People become more hyper specialist, and it's good because we have such complex supply chains, and everybody's got to do their bit. And they haven't even really touched on like consumer products, where you like think about the effort that goes into creating a phone, and it's all over the world, and everything's being shipped around, and everybody just has to be very good at creating their microchips, and you don't have to worry about what it looks like at the end. But for net zero, there's a lot of kind of even like ones that counterbalance themselves, where when you start saying, we're going to, like I said, use a lot more batteries, it's like where you're going to get all the lithium from for that. Or if we're going to use concrete.
And what do you do with them after? Because we can't recycle a lot of them.
Yeah.
So.
And that's what we talk about, this kind of a housing theory of everything paradox. And kind of back to the housing crisis type, or the housing affordability crisis, is that, trying to create net zero homes, and there's a future home standards coming in 2 years' time, and if homes do become net zero, they will naturally become more expensive. But by their nature, usually with existing, we say modern methods of construction, but they're not modern because they've been around for a long time. I say that we're doing postmodern methods because it's like it's a little bit step forward. But current modern methods of construction are way more expensive than even traditional, which most houses are built from. Which means if we're going to get net zero, houses will get more expensive. The housing crisis gets even worse, and that's the other dilemma. Is like, how do we factor in go get onto a whole ethical issue of how do we factor in the societal damage from climate change to the economic damage of the costs of kind of climate resiliency, and that's why we're looking at housing in particular, because this housing theory of everything is that a lot of socioeconomic problems come from housing. So like having proper affordable, like not being able to afford your own home, having to pay rent, where you're like paying lots of money out all the time, where you could have just been paying for a mortgage, and the huge markup on homes compared to the fundamental intrinsic cost. and it's like how can we make sure that we're not exacerbating those issues? So we also don't want to get to a net zero world where we're like, yeah, we've fixed it, we're net zero, but it's only for the rich, and everybody else who's like can't afford it is just kind of like, even in, well, yeah, sure. I think at that point, energy will be so cheap. I think in this interim point, we're going to be in an awkward situation where things are going to get more expensive because they're net zero, and until energy is negligibly like worthless, things will get more expensive. So that's why we came in with this new method of robotic construction, which is way cheaper to build, but it's way better quality and way more robust and net zero all in one. And it's only possible by looking at it holistically, by looking at it at all the stakeholders within construction. So from an architect's point of view, we always work with the client and the developer and the financer, and you've got to think of everything, like a deep dive, so then you could have appreciation of something that fits into the industry. Because even we talked about 3D printing before, and it sounds kind of good in principle, but there's a lot of little bits where when you get down the line, it's like very hard to get insurance for instance. So if you wanted to build a 3D printing house now, it's very difficult to get insurance even for modern methods of construction, let alone 3D printing, where not a single one has existed for more than 10 years. And now we've got this problem with these concrete aerated buildings collapsing anyway at schools. It's like, it's going to be a long time before you can get a mortgage on that, like a bank to give you a 30-year mortgage on a 3D printed house. So a lot of them have to be sold with cash. So that doesn't help an affordability price. But yeah, people aren't looking at it holistically. You can be like, oh yeah, we're going to 3D print a house. And you go, oh, we'll do it. And you're like, oh, we can't get it insured and we can't get it mortgaged. So yeah, it's like you have to look at every kind of step of the way and try and kind of, instead of trying to shoehorn something in, it kind of has to look holistically. And particularly in construction, that's why it's so bad, and that's why emissions are so bad. It's so fragmented. Like even what was saying, there's very few people who have got so many specialist careers, like engineer, but they're actually like structural engineer, environmental engineer, and like a fire engineer. So you've got to be like,
but that's the thing, you have to say, or they're a structural engineer or a fire engineer. They don't sort of do all of these things.
If we're going to create these solutions, these miracle solutions that fix climate change, you have to take into account like so many different things. It's got to be almost a global level effort, but obviously politically that's not going to happen. But from an entrepreneur's point of view, it's good to kind of bear in mind, like that's why these GBIPs are really good. It's you got to bring in like all this understanding from like so many different kind of ways, and a technology might work in one domain and not another domain. So if you imagine trying to fix something like emissions in house construction or building in general, you can maybe create a solution that works well in Dubai or Saudi or Texas, for instance, where it doesn't rain. But then you try and put that in a temperate climate where it's cold and then it's raining all the time. It's like, well, then you can't. It's hard to maybe use robotics in a place where it's raining all the time, or using 3D printing when it's raining, and then the concrete is just going to disappear. Yeah. So you need I think there is a bit of a call to arms in a global effort, but it's going to take, every industry has to change to net zero, which is why, you need a lot more entrepreneurs, a lot more people doing kind of entrepreneurial things, creating all this industry. And that's actually part of my course is Business for Architects, and it's like a mini incubator where the architects come on, and I try and we teach them all the issues in the world and like we're talking about now, and then I kind of give them a little spark of inspiration which they can then run through in a business model. And a lot of them have really good problem solving and visualization skills and really good ideas, but like I said before, architects don't have the business acumen to back it up. So there's lots of good ideas in the industry that never see the light of day because the people we're so fixated on our little siloed bit of design that we don't think, oh, we could go off into entrepreneurship.
Yeah, absolutely. I mean, landscape architects are much the same. Yeah. The landscape architects are good because they tend to have I would say a slightly broader view, but the nature of what we do, it tends to be looking at more like how all these bigger things sort of tie together. It's a bit more urban designy, really, I suppose. But people tend to be a bit more introverted, and I find that quite often could be stifle quite a lot of like the ideas that come forward as people a bit more trepidation about saying what they necessarily really think, or proposing like these new things, or setting up own businesses or things. So
it's true.
I think it's interesting as well, like you see those different like character traits through the different professions that people sort of migrate into, which can then cause their own sort of problems or challenges to sort of overcome.
True.
I always find it's just quite interesting to see how different people fit into these different categories, and you can't generalize everybody the same, of course, but you do see like there tends to be more of like a certain characteristics that go into that sort of specific area.
Yeah, I think it's probably part of the HR policy, maybe.
Yeah, maybe.
Because I think that's when at Big, it was like they definitely, it helped to be more confident in what you're doing, because if you're designing a whole city for like MBS or you're working with Elon Musk or someone, then you have to be pretty self-assured, like this is what we're going to do. You're going to spend trillions and trillions of dollars on this thing, and
you've got to be sure
this is the right one.
They're
not like, are you sure this is the right way we should structure this city? And you're like, well, maybe it could be a square or something. You're like, no, it's like we're doing it like this and it's going to be like that. And so in those regions it is quite like dogged, but in that nature, that's why a lot of it depends on the technology they bring it out, because it doesn't have to be global scale stuff. There can be like little bits about how a piece of what an installation looked like, material science, and the actual research behind it can be pretty strong. So you don't have to be too outspoken. But I think I was seeing, especially like in school, is like as architects, you're kind of like trying to solve problems. You're trying to identify in a brief, this is the issue, and try and design a solution, like architectural or not. And you're supposed to like bring in all the socioeconomic stuff and engineering, and we're supposed to have like a big God level view, but there's very few like architects who are actual entrepreneurs. Like you actually come across in all my time, like all the people in the construction industry that are innovating, always on the engineering side or on the construction side or on the developer side, and there's a big hole in the middle where the architects aren't creating these companies that can actually fix the built environment. And funny, the lecture that I was doing this week was all on smart city tech. So that was the first 2 GBIPs was all smart city tech. I think ours was net zero. And then
it was,
and you'd think all that innovation should come from, say, the architects who have a kind of a God level view on all the problems and issues, but it doesn't. So I think that is one of the.
Well, it goes back to that what I was saying earlier of like the plaster on the wound. Like you kind of end up with like there's lots of technical solutions, but they're not fundamental solutions, if that makes sense. And yes, they are all really important. They all form part of that overall solution. Like for some of the water tech we're doing now, the wider solutions wouldn't be possible without these new sort of breakthroughs, basically. So it is all vital, but at the same time, we know that there's like these bigger sort of fundamental issues that have to sort of be looked at as well. And in some respects, some of them are much harder to resolve than, as you say, just a technology. It has to be kind of a culture change and everything, but it has to but you can't just have a culture change. You need a business to drive that, or a market to drive that change. That's part of the big challenge, isn't it, of getting it forward.
It's true.
On that point though, on the technology side, I just thought it might be worth coming back to the 3D printing.
Right.
Because earlier, and we can't not talk about it, but you talked about the moon base. And you mentioned earlier about some bits with Mars as well. So whilst we're not going to talk a lot about it, I think the context of why there are technological issues in that context that you explained before the podcast is actually really quite useful to help people to understand why 3D printing is perhaps not the best solution.
It's interesting because it's got its uses in certain stuff. And I think this is the kind of issue that I was touching on, was how 3D printing houses just came out the idea of oh, we're 3D printing everything else. Why don't we 3D print a house? And it came, like say, Icon isn't founded by an architect, or it's kind of comes from just the concept of, oh, can we 3D print a house? Theoretically, yes. How would you do it? Well, you could 3D print it with concrete, but no one was really asking the people in the industry, like, is this the right thing to do? You just kind of think, oh, can we do it? And like, yes. And well, it does have its main uses, and that's on the extraterrestrial architecture. So building on the moon and Mars, where you need like full automation and very little like actual machinery that you can deal with, and it's got to be remote. And that's where it fundamentally came from. So big, we developed the moon base. So NASA came to us and said they don't know like how to build it, like can we figure it out? And then we went to Icon and said, oh, can you help 3D print this thing? Because we thought most likely 3D printing is going to be the best solution. And then NASA gave us like moon dust to look at, and we kind of figured out that you could potentially use that regolith to turn it into like 3D print with. And then Icon wasn't as massive at the time, but they had the Vulcan system where they were printing, and they were probably the world leaders. And then we kind of brought them on and helped them kind of get this NASA contract. And now they're like multi-billion-dollar, like worth $5 billion or something. And we were also like designing all the houses in Texas for them. And I think Big is now basically all the houses, like designed all their houses for it. And it's really impressive tech to actually 3D print it. And there's a lot of huge amounts of R&D, and it's amazing. And if they can actually pull it off and get the moon base built by sending out like one arm that just plugs into the ground and it can churn up the regolith, and then if you see it, you can just look up moon base by Bjarke Ingels Group. They're all like donut shaped because you put the arm in the middle and it picks up the regolith, and then it can churn it out in like a torus. But how it's done on Earth, that's not as useful because you really don't want torus-shaped buildings. That was useful because you could, you had to pile it up to stop it from like meteorite impact and moonquakes, and it's very bespoke. But in terms of housing, it's a bit annoying having like a circular house.
Well, yeah, indeed. It's also because of things like you can't get the material there, so you're sort of bound by whatever is already there.
Yeah.
And then also to your original point, just quickly, I think one of the reasons, because even I was like, 3D printing houses, logically it makes so much sense. You stick a robot there, it does everything, and bam, you've got a house.
Yeah.
But as you pointed out, actually, logically, there's a lot more that goes into a house than just plonking a load of material somewhere.
Yeah, that's because we were the one also in charge of trying to take their technology, the Vulcan, and design the houses for it. And we kept coming up against this problem of you can't 3D print flat surfaces. Yeah. So, and there's a lot of flat surfaces in a house because you've got floors, and at the moment, and a roof. And at the moment, their technology, Icon's technology, they can only do single-story buildings. And there's also an issue of just the labour intensiveness because you can't print the gaps in for like a window because there's obviously there's nothing on to go against. Yeah. So you always need people there to put the lintels in, and then so you still need people on site. It's not like completely autonomous. And then you also need to set up the rig, which is annoying because it works like a 3D printer. Yeah. So you have the big posts, and it's got to be rigid, and they have their own foundations. So it takes a lot of effort to dig out the pads, put extra foundations, then put the rig on just to print one small single story, and you're limited by the size of the rig because of it can't just be like flopping around. It's got to be super, super rigid. So it uses a lot of material. So there's limits on the spans that they can do. And then you take it out and you've got to dig the pads up. And it just all goes into landfill, and you're like, you just wasted all this concrete, and then you have to move the thing next door. So there's a huge laydown time of, okay, you can 3D print just the walls, and you have to take all this machine down, take out the pads, move it to the next site, build another one. So for scale, it's not good. It's not well, it's decent, but it's not as efficient as like our system. Because if you was going to go from like start to finish, from like having the foundations to a finished house, it takes weeks even with 3D printing, because you then have to bring the roof on top. You have to then put the walls in. You have to add the floors in separately, and we can do all of that in like 8 hours, where something that would take them several days, several weeks even to do it. But that was only from looking at it from a proper point of view, where if an architect was designing a 3D printing thing, you'd instantly be like, how am I going to 3D print the floors? And how am I going to 3D print the roof? And also, how is this better than just using formwork? Because when we're doing towers, you use just concrete formwork, and you have like a prefabricated set of walls, and you can do the floor at the same time, and you just bring everything to site, clip them all together, you pour the concrete in, and then you wait a few days for it to set, and then you can move the thing up and do another one. That's how they do concrete cores in towers, and that's quicker and cheaper and as labor intensive as 3D printing. So you kind of look at it and say, oh, 3D printing is a great idea, and someone said, oh yeah, let's do it, but no one ever said, is this any better than the concrete formwork that we're doing right now?
Yeah.
Where you can actually do the roof and the floor at the same time. So that's their biggest competitor, is just concrete formwork, and which has been around for decades and is tried and true, and everyone does it, and it's cheap and easy.
Yeah, just general prefab.
Yeah.
Anything prefab, I guess.
Yeah, or prefabricated. You could just prefabricate the concrete panels. Because if the real problem with the housing crisis, or the benefit of 3D printing, is you don't need the labor.
Yeah.
It makes things a little bit cheaper. It means you can theoretically do things a bit quicker, therefore it's better for scale. It should be better for scale, but its kind of competitor is formwork, where it's already really quick and easy and people can do it at scale, doesn't use that much labor, or prefabricated concrete, where you create all the concrete in a factory, and then you just stick it together on site, and you can do the floor and the walls at the same time. The main use case for 3D printing is like one-off bespoke housing, where if you wanted, some millionaire wants to create some crazy shaped building that's really funky and curved, and it's all over the place, and you can create some crazy parametric shapes that are obviously impossible with orthogonal buildings. But if you're just trying to do a orthogonal house to try and solve the housing crisis, it doesn't help as much.
It's not viable because all the knock-on impacts are so great.
Yeah.
You've got to all have bespoke furniture and all that kind of thing.
Yeah, and then the other issues is how, just to keep it physically rigid, you have two skins that are being printed, and they have to connect at some point while it's being printed. And you can have someone going around putting wall ties, but a lot of the time you make the concrete like zigzag inside, and that creates thermal bridging, which means that if it's really cold outside, you bring in letting the heat out, it comes in, and you get damp, like cold spots. And that's why a lot of the 3D printing is only currently happening in like Texas, Dubai, Saudi, where it's not really cold. If you try and take that to a temperate climate like that now, you try 3D printing with current methods, you'd just get mold everywhere on the inside, or just lots of condensation. So at the moment, it's not quite there yet. And then the obvious point is that it's concrete. Like I just said before, concrete is one of the worst emissions of carbon. And there's places like Texas where houses are currently made from timber, and now they're saying, oh, let's make them from concrete. It's like they were currently relatively low carbon, and now they're all out of concrete. And because you can't put that much aggregate into it, because it's got to be very fine kind of nose, like you can with prefabricated, it's all very high in cement. The carbon emissions are just off the scale. So it's way, way worse for the environment than even a traditional brick-built house, and then obviously way worse than a timber house. So it's kind of a step in the wrong direction to kind of start printing in that. So it's quite nice, and if they can fix zero carbon cement, and they can maybe fix multi-story concrete so that you could do the tall buildings, because at the moment we're focusing on timber, which by building regulation standards is only limited to 6 stories, but that's like 96% of all buildings on Earth, about less than 6 stories. But for the really tall ones, it would be good to have a rig that could keep jacking up, and you could kind of just keep 3D printing a core with zero carbon. Or you could 3D print foundations and all these sorts of stuff. For like one-off, really bespoke stuff, 3D printing's good. But if you're trying to solve a housing crisis, it's not great. And that's funny how, actually right now, Icon has a competition to try and fix that for like low cost housing. It's a competition for designers to try and design it. It's like £100,000 prize if you can make it work. But I was joking about it with some friends, because we know that it's not going to work. And they've conveniently left off how you don't have to worry about carbon emissions because the carbon emissions are like pretty through the roof. And I think they've figured it out. It wants to be $100,000 home, and they're costing it like $2,000 a meter squared, which means it's like a 50 square meter home, which is too small to be built in this country anyway. So yeah, I think there's a long way. There's technologies coming, but what we tried to do is look at the technologies that exist right now that you can get mortgages for, you can get insurance for, that are tried and true, and a lot of the mechanization or the robotics fundamentally exists in other industries, and how we could bring all that together to solve those issues rather than kind of trying to shoehorn something in, kind of go for more of a simultaneously top and bottom approach rather than just a top down of, oh, we can 3D print with concrete now go and do something with it. So yeah, it's definitely a challenge. But for extraterrestrial construction, it's the game changer.
Well,
So,
the other thing you mentioned on the extraterrestrial side, just because I know it's something people are interested in,
yeah,
was around the sort of thermal bridging side and the fact you didn't need as much insulation in the walls, which I found really surprising because it's incredibly cold in space.
yeah.
If anyone's seen Star Wars, they know space is cold and horrible.
Yeah, exactly.
But
It's true.
So how does that work?
So the problem is that it's cold fundamentally because there's no atmosphere to speak of as such, and if you did take off your spacesuit in space, it would be more of the pressure that killed you first rather than freezing to death. That's why your head explodes or whatever. It's like that's more of an issue than the being too cold. And then when you look at something like the space station, obviously that's why it's circular, but how you'd imagine that just the house behind there's 200 thick walls of insulation just in case it's 0 degrees outside, let alone if it's minus 250. So you imagine, and it's all a linear progression. So because you base your U values on the temperature difference inside and out. So you'd imagine if it's going to be extra 10 times the difference, the insulation is going to have to be like 2 meters thick or something. So you'd imagine that the space station should have walls 2 meter thick just of insulation. Or when I was building on the moon, it's like, how would you get the insulation there? How are you going to build 2 meters thick of insulation? It's not going to work. But the point is that because there's no atmosphere on the moon, this is all based on NASA's research. They're like, oh, you don't actually need the insulation because the atmosphere is the thing that's wicking away. It's kind of hitting against the side and drawing the energy from inside. So if there's no air to carry the energy away, it just kind of sits there. So yeah, that was quite an interesting one, because we were initially looking at it being like doing the calculations, thinking, oh, there's no way the amount of energy you'd expend trying to keep up with the amount that's being lost. You still have to have a bit of aerogel to stop it going through the ground into the core, and there's a bit of like a vacuum separation there. But as long as you've got a vacuum around, because space is a vacuum, then the energy can't be transmitted like out of it, which is quite nice. But then, you still had to be very thick walls of just solid mass, just of thermal mass. So you'd print the structure, and then you can pile bits of regolith on top, or you just kind of keep printing it quite thick. Because fundamentally, all you need to do is create just a container to stop the air fundamentally escaping, and you'd probably be all right. But if you keep piling more and more regolith on top, which is what we did, then you would, one, stop it from meteorite strikes, and then 2, it means that it stops the UV coming out, getting in, and then also helps stop the heat getting all the way through from exposure to the sun. But yeah, it's definitely quite interesting. And I think they're sending up the first stages next year. So it's Project Artemis. That's what it's all part of. That's what we did. And they're sending up with SpaceX some of the stuff next year. So we'll see if it actually works. But that's one of the interesting things. A lot of our tech, like aeroponics, comes from NASA and the space station. And NASA's obviously really pushing the limits. And they're effectively, putting a lot of money into making this Vulcan 3D printer kind of work. It's just, it will be amazing for building on Mars and building on the Moon or wherever we want. But actually on Earth, it's still good. It's just not the most efficient. Like it's great for super hostile, like low gravity environments. But here we've got, something better to kind of deal with. But yeah, we'll kind of see what happens. I think it will be really interesting. But there's loads of different angles. You could prefabricate stages and stick them on the top. Or, I was talking earlier, you could dig in underneath. But at the moment, 3D printing with the regolith was considered the best way to get because all you have to do is just send up the arm, the system. You just send the system, and you can then keep moving it around and do it. If you sent it as a full stage that had to be built like the space station, you have to keep sending more and more stages. Where here you could theoretically just keep building these structures, and and you can kind of bury them under the ground so they're a bit more protected from sunlight.
So we just had to scoot round quickly because we're burning in the sun. But okay, for anyone watching and wondering why we've moved.
Yeah.
So I think we've talked a lot about kind of generally what you're up to. And I need to caveat the episode here slightly because we can't see exactly what you're doing or talk about exactly what you're doing because it's still really deep in R&D and there's lots of IP issues and things like that. So we're not going to talk about exactly what you're doing. But hopefully people have been getting a gist of kind of generally what's going on. And that is a new way of building stuff, basically.
Exactly.
So do we want to talk a little bit about what we can talk about in terms of what you're currently doing?
Yes.
And I can't say much more. So I'll leave it to you.
That's it.
Because I tie myself in knots. Yeah.
No, you're right. Yeah, because we're quite waiting on the patent. We sort of have to keep being stealth mode for a bit. But it's talk generally about it. You can kind of get the idea that a lot of the stuff that I was involved in before was quite deep tech, high tech construction, really advanced kind of methods, and had a kind of deep dive into lots of different ways of building, and then try to take that expertise into another way of thinking, or approaching it from a net zero and a housing crisis kind of point of view, and taking in stuff that I learned from being in construction. So I've got kind of good background in construction, worked on building sites a lot, and we built these houses here, and say like the first one that we did, learnt a lot. And it was after doing that 5 years ago that I kind of started thinking maybe this could be better. And then after working at Big, realized, it could be better. And we could take in different methods of thinking, and you could integrate it, and you can do something about it. So we're kind of a similar value proposition to Icon and 3D printing, but we have net zero, and we can do it cheaper and with basically less cost and quicker. And another kind of aspect of it is trying to just reduce the amount of labour, the labour intensity of construction, because ultimately productivity in construction hasn't changed for 100 years, whereas something like farming has improved sort of 16-fold. I think manufacturing is about 8-fold in increase in productivity through mechanisation. But actually, if you're on a building site, sure, there's diggers and cranes and stuff like that, but fundamentally a lot of what we do on the site is still very, very labour intensive. And we actually have a two-pronged problem where one, the labour is getting super expensive because generally it's getting more like costly to find the people to do the job, because nobody wants to work in construction. So for instance, in the UK, we have a massive labour shortage of like 250,000 people that we need, and after like Brexit, that's even worse because there's less people coming from the continent. So we're in a bit of an issue where the people that you can get to do the labour are now going massively up in price because you can't physically get them. And so therefore, if we can bring robotics onto the construction site, or just try and automate as much of the supply chain as possible, we can reduce the amount of labour needed, which means that the cost involved goes down. But also, you can't even get the jobs anyway, so it means that we can build more. Because if we've got a 250,000 labour shortage, then if we can meet that need through robotics, then we can build more housing, and building more housing just effectively makes it cheaper in general. So we're theoretically just developing lots of different technologies, and there's some in the garage behind us, and there's some that we're developing in around the world and with different people, and they're all doing their own little bit, and it all kind of goes into this supply chain that we've made up, and it's very particularly engineered so that it still works within building control and kind of works with the planners, and it works with the banks, and it works with the insurers, and it's also good for the contractors to use. Developers like it, architects like it, the consumer likes it. It's trying to tick all the boxes of the stakeholders and the engineers and stuff. So you have to kind of mediate all these different parties, and it's kind of one thing of trying to come up with the idea, and then another of putting it into reality, of like trying to develop the technology and develop it at scale, because that's like Elon Musk always says, it's like easier to do the kind of prototype, but then putting it to practice is really hard. So you got like Lucid Motors or someone who can say, oh, we've got a battery that can last 1,000 miles, but it's like, yeah, try and mass produce that for mass production. And that's kind of the issue we're up against, where we can develop these systems to kind of build the housing, say like 3D printers do, but it's then developing that such a way that you could be building millions of homes a year, which is the necessary thing. Like I think the World Bank says that we need to build 2 billion homes over the next 80 years, which is like 25 million homes per year that need to be built, which is a lot. And if we're trying to develop a technology to meet that kind of demand, 3D printing cannot physically go quick enough. Like you have to build all the rigs individually. So we've been developing a system that is scalable as well, and has an economy of scale, which is the thing that's missing from construction. So usually when you build a house, it's just as expensive to build the next house,
Yeah.
Whereas for us, we've developed a method where it's cheaper the more houses that you build. So it's perfect for sites of like thousands of houses, and it means that the more houses you build, the cheaper they are to build, which is that's the real kind of game changer, which is kind of what we're doing differently. But the way that we're doing it exactly, I can't say.
That's right. Well, on that note, shall we go and see some of the houses that you've been working on so far?
Yeah, we can have a look. We can have a walk around.
Have a look at the one behind us, if that's all right.
Yeah, we can.
And then you can explain a bit about what you can say about what you've done, why you made the decisions you have in the design, and why things perhaps are done a certain way, just so people can understand a bit more about what really makes a home sort of net zero, and sort of the energy saving and technologies that you've introduced.
It's true, yeah. Because I'm also a certified passive house designer, so I did the course, and it's like a nightmare to get the certification. And so I've also been applying those kind of principles on top of the net zero principles, on top of zero carbon stuff. And the house behind, we tried to load up with a load of technology. It's just been in, it's in the Grand Designs magazine. It wasn't on Grand Designs TV show, but it's in the magazine. Home Building and Renovating magazine. Won an award for the best house in the region. So it's kind of really pushing the boundaries at the moment. But it's trying to be a real combination of typology and in relation to context. So it's not like a super avant-garde design. It's supposed to be respectful to the surroundings. We're right next to a Grade 1 listed church. We're not in a conservation area, but there's protected views, and there's lots of trees. So it wants to be integrated. So this is kind of our model home, that we could take this typology, even for somewhere like Lincolnshire. It's like a new typology for Lincolnshire, and we can kind of put it everywhere, and it's a beautiful thing, and it can work well, and we can scale it, and it fits in a lot of locations, and it can still be a really awe-inspiring place to live, and still be cold in the summer and hot in the winter, and barely cost anything to run. So it's not like at the point of net zero over a life carbon assessment. At the time, those didn't really exist when we were doing it, but that there's a lot that we learned from this, pushing the limits on that we're now putting into the full net zero life carbon assessment method. So yeah, we can have a walk around, and I'll point out some of the stuff.
Perfect. Looking forward to it.
Yeah.
Cheers.
Sorry to interrupt, but we have a quick message from one of our sponsors, and it's that we're thrilled to announce that Marshalls is the sponsor of this episode. As the UK's leading supplier of sustainable concrete and natural stone products for the built environment, Marshalls is committed to doing the right things for the right reasons, delivered in the right way, ethically and sustainably. From fairly traded stone to low carbon concrete bricks, Marshalls believes we can create better spaces, putting people, communities and the environment first. Find out more about the firm's green initiatives in our podcast links below.
Okay, so here we are with this fantastic house and a bit more clear view than perhaps we had before. So I don't know, Will, do you want to talk us through a bit of the design and then we can go and have a look inside?
Yeah, exactly. So we designed this sort of 5 years ago and then started construction back in 2019. And it's designed to be practically almost net zero, almost zero carbon on site. So it's built using SIPS panels with kind of rapeseed inside them. So it's like almost net zero itself, using reclaimed bricks, so they're carbon neutral. And it's a lot of timber, all the timber cladding, kind of natural slates. And then we've got solar panels on the roof, rainwater harvester, a air source heat pump, and mechanically ventilated heat recovery system. So there's the vents on the top for the MVHR. And it's also kind of uses passive house principles of there's not much kind of solar glazing to limit the solar gain, but we get quite a lot through the big windows on the east side and kind of on the west side. And then because of the big mature trees around here, usually I kind of see now as the sun comes around even in the evening in the summer, they help create shading on that side. So we don't get too much solar gain through this big gable end. But it's kind of designed as a new typology for Lincolnshire in a way. So it's taking reference from sort of farmhouses in the area. It's a very agrarian area. But also we're right next to the Grade 1 listed church. And this was like very close to an important open space. And then the house next door, which we initially did and renovated, that was a non-designated heritage asset. So we had to be very sensitive in the design. And what we originally did on the house next door is it's covered in, well, it's all renovated, but there's a big extension on the side that's kind of steel and glass. And the steel is sort of standing seam grey, and it looks very similar to the lead on the church. So it's pretty much identical. So there's this dialogue between the church and then church house. So when you kind of stood there, it kind of feels very in keeping, even though it's a steel and glass object. It's like contextual. And we kind of wanted to keep that narrative going, but in a much more kind of low embodied energy response. So we still have that standing seam feel of like the ridges, which is similar to the lead on the roof. And because it's larch cladding, it kind of gets bleached with the sun, so it goes grey.
Yeah.
And it's still in kind of, there's like this triple now trialogue between the three buildings of the 1100 or 1,000-year-old church basically, and then church house, and then now orchard house. And that kind of timber, I wanted to kind of tie it in more with the reclaimed brick instead of it being too dissimilar. So the board and batten texture kind of flows down the front side, so it kind of helps to tie together all of the reclaimed bricks, because they're all quite different, the reclaimed bricks. Some of them have got paint on them, some of them are different colours. But then this means we could have just got any brick and it would kind of make it look good.
Yeah, that's it. No, I think that works really well. I really like the way they blend together.
Yeah.
And I really like the range of bricks as well. I think it just gives it a much more, well, of course it's a much more mottled look by the nature of things, but it makes it feel like it's been there a lot longer because of that.
Yeah,
it looks like it's had something sort of done to it to make it bed into the place. So
it's true.
I think it's really nice.
That's what's really cool about reclaimed, because when you get really close to it, it still holds up. That you can see like the handprints and like the old pieces of grass which they use to kind of mold it also. If you still, and you're reclaiming them, so you're reusing them as zero carbon, and you can actually, it feels like it instantly settles the building in the context rather than looking a bit too fake and stark. And then as well, the larch used to be a lot deeper colour that you can kind of see under the windows where they're a bit more protected by the sun. But as it kind of settles in, the idea was, because we're surrounded by the trees, that striping kind of works like a zebra stripes, and it helps break up the form a lot more, especially when it's seen through these trees. Like you can see to the right, there's all these verticality of the trees. And when you see it from that view, it actually kind of blends in a bit. You can't really see the exact extent of the building, so it doesn't feel imposing. Because there's the main road beside us, and they wanted to keep the character of the village, right? So it sort of blends into these surroundings, and it also creates kind of like a nice private glade here. So
Yeah, absolutely. I think one point on that as well, where you've talked about these large sort of boundary trees that are sort of behind the camera usefully, but they play a really important role in looking at the sustainability of buildings, because obviously in the UK we talk more about sort of keeping heat in and reducing energy use in terms of keeping the houses warm. But as the climate gets warmer, obviously houses are going to be subject to a lot more heat and longer periods of hot weather. So making sure that the trees are there to help shade it in the summer as well is just as important as considering some of those other factors. And, you know, if we can do that effectively, it reduces either the need for air conditioning, which is one of the biggest energy users in the world. So you might be able to omit that completely through good design, or you have to use it a lot less. So there's a lot less energy use in its application anyway.
Yeah, exactly. I think that's kind of the theory, which you always think about when you do a section and you draw the diagrams, and it kind of does pretty much work out that it's only really in the worst heat, where it's super high stress, like where it's 40 degrees or something, that you have to rely on cross ventilation for it. But usually, if the building is, you know, got the windows closed and it's not letting that hot air in, it actually generally keeps pretty cool on its own. And then as long as because most risk of overheating in the evening when the sun can go straight in and it's hotter, because the trees are here, it helps protect it. And this is called Orchard House, so it was the orchard for Church House, and that's why we've got pear tree and apple trees all around. And then we tried to keep as many trees as we could, so it's in the shape it is so that it can fit around those trees. So I tried to create kind of like a succinct kind of rationale to it. So the way the building works, it's got one central gabled section in the middle, which is just like a long barn shape. And there's these two orthogonal sort of structures that sort of emerge from that piece. So you have, and they're all lined up perfectly with the top of the cladding. So it feels like you've just got this sort of oblong shape that's protruding from the section, but it's actually kind of also working around the trees, and they're exactly opposite. And it's all kind of perfectly formed. So this gable end is a perfect square, and it's also the same depth going back. So it's like there's a perfect cube sat right here, and on the other side it's like a perfect half cube, it cut up, and then the forms inside are then another two cubes and then another half cube. So it's all like on exact module, and that's all kind of based off the size of a brick. So these are actually slightly weird shaped bricks because they're reclaimed, so they're slightly wider. But that then was able to determine basically the grid of the cladding. So you can actually see that the cladding and the battens line up exactly with the mortar joints, like everywhere. It's all perfectly aligned, and they align perfectly with all the windows, and it's all super neat. And then that's all determines the whole grid and module of the thing. So it seems quite kind of simple, but there's lots of little details that really bring it. Like the cladding has invisible fixings, which we kind of developed ourselves, and because we built this ourselves, and we built the cladding ourselves. We made all the panels. We made them in the bedroom, and then we'll bring them out and then stick them on, and they'll have like an invisible fixing, so you can't see any. There's no screws, there's no nails, so it's super clean. And there's actually a neighbour who tried to copy it because they loved it so much, but they didn't know how to do it, so they just drilled it. And the problem is that after time it rusts, and you get these streaks down it. Where now this has been in 4 years, and it still looks super clean. It's like super fresh. So it was a lot of effort figuring it all out and getting it done, but you end up with a really kind of high-end sort of finish, which is really cool. So
no, it looks fantastic. And then the only other thing to mention, I think, was about the solar panels.
Oh yeah. So that's the other thing. We weren't allowed to put solar on the gables. It just couldn't be visible because it's in a protected area. It couldn't be near the church, but they're currently hidden on the parapet. So that flat building isn't just because it's protruding out of the internal mass. It's got a small parapet that kind of has the solar on it. So you won't actually be able to see the solar around, and there's one on the other side as well. So that enables us to still get a lot of harness the solar gain without kind of compromising the aesthetic or planning. So it was quite a neat solution instead of either just not having it or putting another gable end here, which we couldn't have done.
Mhm.
You know, there's a lot of kind of, I like to do two things at once.
Yeah.
You know, that's the benefit of it. It's like, it kind of looks really cool and it's a perfect cube and you get a flat roof, but then it also enabled us to put the solar in without hiding. So it was,
I think now it looks really good.
yeah, it's kind of, now that it's getting kind of settled in, and it took a long time. It was a long time fighting the planners to get it. And yeah, initially they were pretty heavily against it, but we kind of proved that it will kind of really assimilate into the environment, you know, because it's a very verdant area and they don't want, because the main view as you come in over a bridge and you look straight at this site, but now they're kind of like, oh yeah, you're right, because you can barely see it, and the bits that you can see, it's just kind of broken up by the trees, and it's kind of really well assimilated and it's sustainable, and it didn't cost that much more because we did it. So, you know, a normal house in the area of this size could cost like 600 or 700 grand or something, but it cost like 250, 300 grand to build. So, you know, you could have bought a pretty bog standard house next door, which is just like any other, like built traditional and with none of the sustainability credentials. Or we could have just built it ourselves and you'd get a much better finish to it. So yeah, it's definitely worth doing it. And then yeah, my parents were the client were super happy as well.
Perfect.
Because they didn't, initially, it was good that they waited, because I'd done a few houses before this for other clients, and then I learned a lot from them, and then I could like put in kind of, you know, where to push the boundaries once you can kind of walk before you can run. I knew, okay, we could do a cladding system like this, and we have this kind of shadow gap gutter detail which I'd designed on some other houses, and I know how that could work, you know, and how we could get the people to kind of fit that in. You can actually see it more on the other side, and then how we could do it with the SIPS panels. And then it was really from this that I then learned even more, and from being on site and seeing the construction, that then gave me the ideas to push the boundaries of the construction processes rather than just dealing with what we've already got. We could kind of like how we could, you don't have to be reliant. It's like with the cladding system, we didn't have to rely on what was in the market. Like, oh, you could develop something yourself, especially because we were doing it ourselves. So that enabled us to be really innovative. And then it's the next one, we've then gone even more further, and then we're hoping on the one after that we could keep on adding more and more innovations into bits.
Yeah, that's a good idea.
Pretty cool.
So we'll just
around a bit.
wander around to the front
Yeah.
and have a look from that. Unless there's any details we want to point out as we go around.
Yeah, it's just that we kind of continue these kind of slit windows, kind of like arrow holes, because on the church they have these really kind of verticality, all these kind of Gothic windows with the kind of murder hole kind of arrow slits on them all the way up the church. And well, actually on the church house side, they have windows like this facing out into the church, and then we want to kind of continue that in, but it also means that you don't get too much solar gain on this south side, but it kind of helps that verticality, and then on this side going up. And then I just wanted, it's difficult to see, but yeah, there's like a shadow gap roof detail on the eaves that's really difficult to do. It kind of, there's loads of little bits where it's like, if you're an architect and you look at that, you're like, oh, that's really kind of tricky to get all those bits to line up. That's quite fancy. And then making sure that, you know, we had this continuous sort of bead that goes across the top of the bricks, so that can the anthracite, and then that kind of comes all the way around to, you know, across the face of the building to kind of then line up with the soffit underneath, because where it kind of steps under. So you have like this continuous bead. It looks like it's just a, you know, the top of the brickwork. Then it goes around so that it's one continuous piece. So there's not like a stepping. It's like quite a neat little detail. Because then that creates this recess, which is the entrance, so that when you arrive and you're trying to take the keys out and you're not getting kind of covered in, you're not getting rained on. And you can see this is the other little step out, and the drive, and where there's kind of like a more protected space in here, and the big tall windows, like a scaled up version of those arrow slits, and that's where the staircase goes up. So as you walk up the staircase, you initially can't see over the garage, but then as you get to the top, you can kind of see out into the rest of the garden, like over the way.
Oh, okay.
So it's like a lot of clean, kind of very neat, like tectonic details. We're trying to just do everything right. We line everything up and use the authenticity of the materials, because those planks of wood are just like raw pieces of larch. You never cut them to the size, and
Yeah.
we're trying to make everything work exactly with the supply chain, rather than saying, oh, I'd rather it was this size and you have to cut everything to fit.
Yeah.
It's like we made everything so it was as efficient as kind of possible.
No, it looks really good. I really like it.
Yeah,
Okay.
it's turned out all right. I can't really think of too many things that I would have done differently.
No, I said when I first arrived to you that this is how I want my house to look.
Yeah,
So,
yeah. It's something which is a bit unassuming, where you think, it's not too showy to be like, it's this crazy postmodern thing, but it's really neat details that work on making kind of sustainable stuff look good and still be cost effective and be easier to build. And this was in Architects Journal, and like I said, Grand Designs magazine, and it's won a load of awards, and it's it's kind of can be worked as a new typology. We always say that saving the Earth doesn't have to cost the planet. No, saving the planet doesn't have to cost the Earth. That's what I mean. So it's like you don't have to make it more expensive to get a kind of net zero type building, and that's what was proving here. And we could do it for one building, and then the next one is to prove that we could do it at scale using our method. So it was fun. It was good, and I've worked a lot on site doing it and learned a lot. So that was why I've kind of a unique expertise, where I go from working in a architect practice at like the biggest possible scale and the biggest possible challenges, to then just the small details of making sure you have a level threshold detail and how that actually works into the rest of the landscaping, or how you make this little soffit kind of line up, or how could you build this sort of thing at scale so more people could also enjoy it. So it's useful to be able to bring the big scale into the small scale. Like you said, it creates a fully holistic design. It's like when I'm designing, I always imagine it like a Rubik's cube. Every single side you look at it has to be right. You can't have like 6 sides, or 4 of the sides all good and then 2 of them aren't right or something. It's got to make sure that everything kind of stacks up in all different directions. So take time and look inside.
Yeah, definitely want to see inside. Absolutely.
But yeah, this is a big vaulted space. So
It's
this
beautiful,
is like,
very airy.
yeah,
It's nice and cool as well on a hot day.
Yeah, exactly. And then we've got sort of lots of light coming in from that right-hand side, and then it's nice that when you're sat here at the desk, and this is where we kind of usually have all the plans out for for the next house. We can kind of sit here, but there's all that light coming in, and then you can also kind of in an evening retire more in this area where there's a log burner where we have biomass, and you can kind of look outside, and that's nice for the evening because it's on the west side. But then you can also come through here and into the kitchen, which kind of wraps around, and that's facing more out into the east side. So when the sun's rising, you have more of like a breakfast area out here where you can hang out and chill more in the morning, and then having a coffee and stuff. It's more on that side. And
with the garden beyond as well, it was just beautiful.
Yeah, it's really something. And the trees still kind of help to block the worst of the morning heat a bit, but it's still good when it gets a bit higher. It's really nice to be sat out here, and it's quite secluded, and you can just look down to the garden. All you can see is trees until we're going to build our other house. But at the moment, it feels really neat. And then there's all the utility with just with the bathroom on the side here. But it kind of works as like a zigzag, so that even when you're sat, you could be sat here, watching TV, and somebody else could be sat there in the same room watching another TV, and it's not affected because like the acoustics are in different directions, and you can sit here hanging out, and someone else can be sat there, and even though it's the same room, you never really disturb each other. You could be here because there's the big void in the middle that takes a lot of the sound out. But
that's something I noticed because I have a bit of a booming voice, and I was thinking, oh gosh, it's going to be very, echoey for us to record in here. Maybe the viewers think differently, but being in here, you really don't
Yeah.
You hear a little bit of an echo, but really not very much. And I was quite surprised as to how you'd sort of tackled that, really, because
Yeah.
you know I don't get involved in building design really.
Yeah,
But
yeah.
it is surprising.
It's true with we've got these engineered floors with engineered timber floors with underfloor heating. So there's that, you know, makes it a little bit worse. But it's just the soft furnishings, got carpet on the top. These kind of bring that verticality back in with the staircase. I've got these little, the handrail is made up of these vertical battens that go all the way up and then round. And that actually helps baffle the acoustics quite a bit, because you've got all these different sides where if you're talking over there, it's actually being kind of passed around quite a lot. If it was just plate glass, you would get a decent echo. They kind of work as a bit of kind of a baffler. And yeah, and then in here it is quite like loud. It's quite a big space, but that's why you get kind of, you come into this initial compression and then you get this kind of release, and it's like a big thing, big airy space, and then you go back into the compression and you're in a more kind of snug area where you know, you don't notice if there is any kind of echo too much.
No.
So, but I also like how there's, you know, you've got the view out through that way, and then you can still look out into this side of the garden with the sink, because this one was kind of the old glade with the old orchard and everything going on it. So there's really nice mature trees, and there's all the squirrels running around it and stuff.
Yeah.
And then it's simultaneously you can look out into this garden on the other side where it's much more new and kind of planted up with much more kind of a formal garden in comparison. So it's actually cool to kind of keep telling those differences, and then you can use it throughout the day. And this is only just usually for my mum and dad, so they can kind of spread out quite easily. It's kind of accommodates them quite well.
Yeah, but it's surprisingly light in here as well. I mean, from the outside, obviously you've got these giant windows,
Yeah.
but they're a lot more noticeable from the inside than when you're outside. They don't actually stand out that much. It's quite interesting how even with such a big glazed area, it kind of blends in.
Yeah.
It's really nicely done.
I like this kind of cave aesthetic where you just kind of sat there and it's like solid walls, and then you're just kind of looking straight out to one end, and it's always about bringing the outside in and kind of creating that quite liminal space, because it's one big sliding door on that side, and it's sliding because they're all lining up with the windows above, and it lines up with the actual brick dims and stuff. But it means that you can, just kind of your eyes can really kind of, it frames that view quite well.
Yeah,
so it's pretty
absolutely,
good.
absolutely.
Yeah, so it's actually not too bad. Yeah, so you kind of get this feeling that's a bit of a TARDIS in a way. Like you might look on the outside and you might expect a completely different space internally, especially with something like the vaulted ceilings or how this is all one big space. You'd kind of see it from the outside and not realise that it's just going to be this so open and kind of airy.
Yeah, indeed. I think
nice.
I think the gable ends play quite a big role in that, because from the outside you obviously, whilst the house doesn't extend much further beyond this one or this one, they kind of like just break up that view, don't they? So it helps bed the house in a bit more, and because you've got the greenery and everything as well in those gaps, again it just softens the whole aesthetic and really beds it in. So it doesn't feel as big as perhaps, because it's a big house. It doesn't. It really doesn't feel that.
Imposing.
As big as perhaps it is. Yeah, it definitely doesn't feel imposing.
It's true. Like if we'd filled in the void, you could have got another bedroom in here or two or something. You know, it could have been a 6-bed house. But it's actually nicer without it, that you get this really amazing kind of space when you come in, and then it's great when you have dinners, and if it's like Christmas and you can all sit around a table. And the main ethos was as well that when people move a bit away from like TVs, this is actually like quite kind of old school in a way, that most people consume content on their phones or...
I don't have a TV.
Yeah, exactly. On iPads and stuff. You're not actually going to design it around on TV, or people will be more siloed in their rooms, you know, like all the bedrooms. So it's quite nice that if people are in their bedrooms, or like when we're there, or when there's like the whole family here, you're still kind of connected. Like you could still be down here and people can be up there, and you still can talk to each other, and you're still not completely separated. I think as more people decentralize kind of from, well, not decentralize from the living room, you're actually still trying to create a nice kind of communal atmosphere.
Yeah, that's it. Well, I think it's nice because everyone has to pass through it, so it automatically kind of has that like meeting place vibe, doesn't it?
Exactly. And when you have this, because there's the kind of walkway that goes all the way around means that it's pretty cool kind of sat up there. And it's always nice sort of working down here. It's got good lighting, or working kind of at the table there. And yeah, there's lots of kind of quite neat spaces which you can kind of travel around in. It wasn't designed to be like too like prosaic, where you kind of, if this is what you do in this location, this is what you do in that location. So I think this is how I'd laid out things in plan, but maybe the next owner, they could maybe put the dining room over there, and you could have like a more of a living area in this centre when you don't need a TV there. You can have it like in the centre, and everyone's just kind of lounging here. So I think it's really
Or you
flexible.
Could see someone putting a big grand piano here or something.
Yeah, exactly. You could do all kinds of stuff. This is because this is the ante room there, but it could also be part of the entrance sequence as well. So you could have something like grand piano or like more of a living room, and then that's the dining room. And then it's also was a bit of a concept that we was going to put curtains in if necessary, because there was one thing was either acoustics, or two, like, if we wanted to divide that section off for whatever reason, that you could theoretically have a big sliding door, because there used to be a window. There was going to be a window plan there, but we took it off thinking, we might put a big sliding wall there that you could bring all the way across. So that was planned, but realised you didn't really need it. It's always been fine to have one big kind of central space that has lots of different options that can be kind of siloed off by the ceiling height, which is quite interesting. Yeah. So I don't know if you want to see anything else.
Yeah, I mean, anything you're happy to show us, I think would be interesting just to see, because it's a beautiful space.
We can go a bit upstairs.
We won't stop for long, but just have a quick.
Yeah, you can kind of
quick nose. If that's
you
all right.
can have a walk up here. Yeah, and I designed the staircase. I think in the next one we're going to design and build it all ourselves, but it's nice that there's kind of.
So you brought this in yourself. This was like purchased, was it, opposed to designed by you guys then?
No, we designed it.
Oh, you did design it?
Yeah. So I designed that and the staircase, and it was all timber, and they wanted to put steel in it, but we put the two big glue lambs on the bottom because that should be enough to do it. But it was always designed that you'd have that one step at the bottom so you can get onto it. So it's all kind of perfectly lined up, that the void is just big enough to kind of accommodate that one step at the base rather than being like two steps or something. And then we've obviously got like the big glue lamb beam at the top that's kind of holding up all the slates, and then the kind of pendant light. And then you can kind of start to get a bit of a different view out the windows. You get those big tall windows. It's one thing downstairs, but then upstairs you can get a lot more light in. So it's quite nice when you're walking up in front of it.
Yeah,
you get different
absolutely.
aspect out. And kind of quickly go in here. I think it's super. There's a bathroom, and then this.
Might just have to wait for Rob to catch up.
Oh yeah, that's fine.
Sorry, Rob.
No, this was the bedroom for me that I designed.
Oh, nice.
So mine has like the vaulted ceiling as well. It's like a really kind of tall space, and it's on the north side, so it actually keeps pretty cool. You can feel in here. It's actually a little bit cooler than outside, because we only have these windows on each side. So I wanted it so that we could have a nice view out that way to the east, but also to the west, so that you can you've always got like sun a lot of the time, and the bits that kind of stick out here are all for the bathrooms. So on top of the little living room before, there's two like little bathrooms that stick out. So that downstairs, it only sticks out 2.5 meters, which is probably a bit too small for something like the living room, but because it's all open space, you don't notice. And then upstairs, that's accommodated for the bathroom. So it's all kind of like a neat arrangement. And then the ceiling heights are always changing in here, because we have big spaces in the bedrooms. They're usually higher, and then in the bathrooms they're always a bit lower. So it means that you get this more kind of compression and release, and this is all a little bit higher in this little walkway, and then you enter the much bigger section there. So it's always kind of playing with the different feelings kind of subconsciously. Yeah. And this bedroom's a little bit taller, because this one has the loft in it. That's underneath. So that's where the MVHR is. So that's all running up there.
MVHR?
is the mechanically ventilated heat recovery system.
So that's little vents.
Yeah, that's what the vents are for, both kicking out air, and it draws in the air from the bathrooms. So it draws in the kind of the dirty, as in like the humid, kind of hot air out of here, and then the heat recovery system warms the incoming clean air with the hot, dirty air going out. So you get to recover a lot of that heat rather than, in a bathroom, if it's really hot and steamy, you'd try to just open the window and you just let out all of that heat. But the heat recovery means that you can just keep the window closed and it's constantly allowing clean air into there without you losing any heat, and you can recover it. So it's it's pretty neat. We've always put them in every house I've ever designed. We've always put it in. It's definitely super useful, and it's getting more efficient all the time. And then you can also couple that with a heat pump. So with a heat pump, air source heat pump, which is then powering stuff like the water cylinder and the central heating, and then that's kind of powered along with the heat recovery by the solar. And so a lot of the regulated energy, which is the stuff just to keep the building functioning, is all covered by solar. It's then like unregulated, which fluctuates, because there can be times where you happen to charge an electric car or something, which is like, it could be variable, or there might be more people in the house or less people in the house, or you're going away on holiday. So that unregulated changes, so it's not covering all the unregulated all the time. But if you could leave the house running for kind of forever. The solar is then keeping it kind of warm and fresh air in here all the time. So you could theoretically leave the house for, go on holiday and come back, and it wouldn't have actually cost you anything, but you'd come back and it's still warm and it's still fresh, and you've not got mold growing everywhere or something. So that's that's quite neat. So I definitely learned a lot, because we tried to do a lot of it like as much as we could ourselves. We didn't have like Offgrid Works set up at the time, but we learned a lot and outsourced like the SIPS panels and obviously the windows and stuff. But we put in, did a lot of the painting, and did the doors, and did a lot of the floors, and tried to do as much work as we could. So learned a lot.
Yeah,
so that's
it's paid off. I think it looks fantastic.
Yeah.
And now you've got the next one started.
Yeah, exactly. It's a high bar, because Church House won the award for best house in the region, and then best extension in the region technically, and then this one best house in the region, and then the next one, building controller. You better get the national award now. So it's like, okay, we'll try. It could do it, I think, if we could. If it's really, really cool, because that one was really, really difficult to get planning, because it was like the unholy trinity of, they thought there was a viewing of a great crested newt on the site 20 years ago. So they said there was no way you could build there because it's endangered species. It was also an important open space, so it means it's protected worse than a green belt, which means that it's illegal to build anything on it. And also it was next to a grade 1 listed asset, which had protected views. So it was like everything you could possibly imagine was a nightmare. So as a planning consultant, people were like, just don't go near it with a barge pole. Like, there's no point. So, but I was like, I'm going to have a go. And then I just went through it all meticulously, one by one, and was kind of on paragraph 80, proving this is going to be like a world-leading design. This is like, no one's ever done anything like this ever. This is completely earth-shattering, which they kind of really got on board with and wanted to do something different. And also we went through it proving with DNA tests that there's no newts, great crested newts, within like a 10-mile radius or something. And also English Heritage came back saying there was no effect on the church. And then we also proved that it's called Hidden House. So there's a huge hedge on the site, which you might go look at. And that actually blinds most of the site. So it's very difficult to see in from any angle. So the whole house is kind of stepped, which means that you can't see it. It's kind of stepping away from the hedge, which means whenever you're stood on public land, it's kind of hidden, blinded by this big hedge, which is already there. So, and they were like, that's kind of fine. If nobody in the public domain could physically see it, then what can they complain about? like who they're protecting.
Absolutely.
Because you have no right to a view from your house.
Mm-hmm.
It's like if someone was to build right there, you can't complain because it's private. In terms of public amenity, they obviously had a right, but we proved that it couldn't be seen, so that remains to be proven. But we did all the calculations. So it's basically like two gables, one smaller than the other, stepping away from the road. And there's like a big, where they meet, there's like a big central atrium that's like got a glazing all the way across the top. So it's like this huge light well in the center that goes all the way through the house. So you can walk on reinforced glass that's opaque, translucent, and it's like laying this light all the way through the center. So it should be pretty cool in the end. And then it helps create stack ventilation to kind of purge if needed, if it gets too hot. But yeah, all the plans are down there, and we
can't see them because it's top secret.
Yeah, you have to wait to see it in real life.
That's it. Once it's built, we'll be back.
Yeah, it won't be hidden anymore. But yeah, it's cool. It's definitely learned a lot from the practicality of like when you're on site and physically been building it, and then realizing how you could push things to be even better. That's a big difference, because a lot of architects never get to go on site, let alone physically build stuff with their own hands. And especially like my colleagues at the Arc Ingalls Group, or everybody I know who are at like the elite end of architecture, don't go on site or don't physically build stuff with their hands, and especially not to this extent where you're like physically building a house and laying the bricks and figuring everything out. And that enabled me to then innovate in areas where I could see the boundaries could be pushed a bit more, and especially in the context of like sustainability and cost efficiency. So it's definitely been a really good experience, but it's been like a decade in the works, really. Like this whole master plan and getting it all figured out. So it takes time. That's the other problem with construction. It just takes so long.
Yeah.
Like the iteration process is like years and years. So you do one house and you're like, oh, I should have done that better. It's not like an app where you go like, oh, I'll just update the app. You're like, oh, I've got to knock the whole thing down, or I've got to build a new one. So I've got to go get some land, get planning permission, get building control, find hundreds of thousands of pounds to build it. So that's why innovation in terms of architecture and design takes so long. But so it's taken 10 years to kind of get to this stage. But I think it will be worth it.
Yeah, I think absolutely. No, it's a worthwhile venture, I think.
Yeah.
And you're young too, so you've got loads of time.
Yeah, that's the other thing. Yeah, that's the benefit. Still, 29, so still got
good age.
Got time to go. But I think, that's the other problem with the industry. Like usually you don't get to a point of like running jobs or building like houses until a lot later, especially not these awards. Like when I used to work at practice not that far away down the road, it was like, would have been a dream come true to win these sort of awards or be in Grand Designs magazine and things. So, and those guys, you're more likely going to be in your 40s or 50s before you start doing that. So, and at that point, you've got, it's hard to take risks, I'd say.
Yeah, indeed. Yeah, because you have families or whatever.
Family and mortgage, and you've got, opportunity costs and stuff. So, maybe the construction tech side, it's good taking risks now, because if it doesn't work out, I've still got the rest of my life to go.
Yeah, that's it.
And then also it's like, it's more personal, because in 2050, we're still going to have quite a long time. Like we'll still be knocking around by 2100, so we've got to make sure the planet's still there.
Well, exactly, yeah. This is what people don't realise, isn't it? We're going to see it in our lifetimes. That's the scary thing. Yeah. Well, one of the scary things.
Exactly. So for a lot of the guys, a lot of the partners, not big, but other companies I worked at, if you're in your 50s or 60s, we look at like Foster or Rogers or I don't know, Chipperfield and all these, the old guard who are like the really big guys. They're all in their 80s and they're not going to be around for much longer. Like, well, Rogers, he's already passed away. So those are the real super influential architects, and they're not going to be here when climate change really kind of kicks in. So it's really down to all of the young blood to kind of really figure out what we're going to be doing.
Yeah, that's it. I think that's the other thing that surprises me. I think a lot of the people coming forward with a lot of the really innovative ideas are around our age, which is like quite surprising. So I haven't aged as well as you. I'm only 1 year older. So,
True.
It's But it's interesting when you go around and meet a lot of these quite innovative or alternative approaches. Like a lot of people do tend to be our sort of age, so you can kind of see like the next generation kind of coming through and having their impact now and bringing forward these ideas, which is also really exciting.
It's true, and I think that's necessary. It's just that in something like, because you see it obviously in tech, quite, and in like shallow tech stuff, as in like apps and all that things. But like in deep tech, it's tough because it's like just to get the expertise, or even in something like construction, even to become an architect, like fully qualified, took
a long
7 years at least. It took me 8, and even then you're like told, oh, you're an architect now, but technically you've only had maybe 2 years of experience, and that time you've probably never even seen a building getting built. Let alone designed it from start to finish. So I was quite fortunate that I had designed and built buildings in that time, but that's extraordinarily rare to see a building from start to finish that you've designed yourself. Because I designed this before I was fully qualified, and I couldn't use it for my part 3 because you had to be supervised by an architect. But I just did it on my own with no supervision, so I couldn't use this in my actual professional qualification, even though I was like, I designed this from scratch all the way through and built it, and it's winning awards. And even it was in the Architect's Journal, and they're like, oh, but it doesn't count towards your actual professional learning. It basically means that it takes a long time to learn, and then you've got to be at least in your 30s before you start to really understand how you can innovate within the industry.
Yeah,
something like that.
That's it. Well, I had a very similar thing. I was representing the UK on the World and European Council for Landscape Architecture when I was at uni. And I was coming back from uni, having been to a World Council meeting where I was one of the delegates, and I come back and say, well, actually, this is kind of what everyone's talking about and what they're doing. And the university would be like, no, you don't know what you're talking about. And I was like, well, actually, the university's like quite a way behind now in terms of what we're actually doing. But they're almost not interested because they're like, no, that's not the way we're doing things. We're looking at it this way. And it's like, I can see the way you're looking at it, but I can see this is perhaps a better way to look at it or a new way to look at it. Maybe we should look at that option perhaps.
It's true.
And it's a very funny kind of dynamic.
Yeah, that's the problem with kind of
the education
authority.
system. Yeah.
It's like, oh, you're not old enough to understand.
Yeah, indeed.
Even if now they've been proved wrong, it's kind of like, well, they're probably all left and not their problem anymore. So
yeah, indeed.
Yeah, but hopefully there will be more people like me. That's why I'm doing my course and teaching people and stuff to kind of get them to do it. Because definitely you do get burnt out pretty quick.
Yeah, that's the trouble. Yeah,
when you're like, especially in architecture, after like 8 years and then slogging in the long hours, and you're just like, oh, I'd rather just, once you're fully qualified, just do my time and just kind of try and learn about the industry. And then it's probably not until you're like in your 40s or something that you start thinking, okay, I kind of get a hold of this now. I can go on my own. And also getting jobs as an architect is really tough because no one trusts you to build anything until you build something.
Yeah.
So you have to get a bit of a brand and a following on Instagram or something.
That's it. Yeah, indeed. It's kind of like we have the same problem where you either have to submit a great big portfolio, which is really difficult if you've left a company and started a new company, because some companies don't want you to show the works you've done or whatever. Or as you say, if you don't have a big Instagram following, especially when you're doing something kind of creative and design led, they don't feel confident in the design. It's because also for planning, a lot of the stuff can look very boring. Whereas you've got someone else that does stuff by more on the ground, so to speak. They've got all those projects with real photos and stuff to show, and it can be very difficult to kind of compare to that.
Yeah, exactly.
It's a big challenge.
Because even for me, now it's just obviously we'll be outcompeted by people who have done, who are in their 50s or 60s or something, who've done loads of homes, and it's pretty standard. You're like, oh, here's all the homes.
Well, it's a safe bet, isn't it? That's the trouble as well.
So you can get people who are like really looking for something really different and really kind of special. But yeah, definitely because I've built stuff, it's been awarded. But to get things going when you're like in your 30s or 40s or something, a lot of people just think, oh, it's going to be way too effort. Unless you already have an insane network by birth or something.
Yeah, indeed. Yeah.
Then
unfortunately,
that's basically
isn't very often the case.
Yeah, but also that's where Zaha comes from, or Chipperfield, Rogers, Foster's, like all those guys kind of started by. But yeah, I think it's definitely it's hard. But I think when you come from a technology point of view, it's actually a little bit easier because if you can come up with a really good idea that works and ticks all the boxes and people get excited about, it is somewhat easier to like raise the capital to kind of make that work. Whereas instead of trying to start a company where you're trying to convince people to let them build your house, it can actually be, there's a lot more of a minefield, because I've made mistakes on projects like back when I was 18, 19 doing stuff, and managed to figure it out and get it over the line, which I wouldn't do now. But it's better to make those mistakes when you're in practice.
Yeah.
And there's somebody else there who's kind of help.
Yeah.
Whereas I was just doing it alone the whole time and managed to just figure it all out. But I kind of know all that now, and you kind of learn from experience.
Well, that's it. It's like I'm a much more baptism of fire kind of guy. I'd rather kind of go and figure it out for ourselves, and then you sort of learn it. I find you learn it quicker and better. Like you sort of understand it to a higher level than perhaps if you just sort of had someone look over your shoulder and go, no, change that.
Do that, and you're like, why did I do that? And they're like, oh, don't worry about it.
Yeah, it's just the way we do it.
Yeah.
That's it. And after that, you're in a much stronger position, and that's what we did with our practice. We set our practice up immediately when we finished uni. And me and my business. Well, I took my master. I was doing my masters and paying for it myself, and I thought, I haven't got any money to start the business, so I took my master's loan and used that to get the business going, basically. So that's kind of how we started. But me and my business partner went to uni together. And now we're 4 months old. Last 2 months ago. A month ago, we were 4 years old, and we've done
4 years old,
20, 30 projects or something like that. So it's not too bad. I know, like I said before, some are small, some are big, but it also takes time to build up that like reputation and get the projects back, because projects go to planning and then they come back again. So it takes a long time to build up that sort of like portfolio and client base and all those kind of things. It's a challenge. But
it's good to do it
once you start doing it, now we're at a point where we like really. I mean, we always knew what we were doing, of course. We're a business, very professional. But now we really get it, and it's kind of like, right, okay, how do we move the business forward now? So it's gone away from that sort of early learning, building stage to now sort of trying to grow the business a bit more and do those things. But going through that process is very difficult if you're in that typical sort of work environment, I'd say.
Yeah. It's definitely if you're going to run the company, you've got to do it to figure out how to do it. You would never learn that in practice, but. In terms of the skills required, it's good to get a little bit of an understanding and then go from there. But
indeed.
But it's good. We can. Oh wow.
Yeah, it's quite late. Shall we have a look at the other house very, very quickly?
Yeah, we can have a quick run over.
We can't see too much because it's still being built and under.
Under wraps.
Under wraps.
Yeah. So then now this is a new development. So this is our next house, called Hidden House. So it's kind of hidden even on Google Maps, and it will be it's kind of using part of our new kind of construction method. We're just putting in the ground floor slab now. We started construction 2 weeks ago, but I designed it almost over 3 years ago, and with this kind of new method involved, and then we've been figuring it all out and building the company up for the past couple of years since we've got planning, and it's going to be like two kind of gable ends, similar to how Orchard House has like one big gable. It's going to be like two gables, almost like the garage, which is just a single story gable, and then the Orchard House gable just kind of combined, and with like a big atrium light well in the middle. So it's kind of set back from this big hedge. So even when you're stood walking by the hedge, you won't be able to see the building because it's kind of way above the top. And then we're going to have all solar tiles on one side, and then heat recovery system, ground source heat pump, rainwater harvester, and battery this time. And then there's a garage at the back where we're also going to put some solar on top of that. So we're going to have lots of solar, lots of energy going on. And it's all timber frame, so it's going to be pretty sustainable, I think. And then the thing that's slightly different is that, which is part of our ethos, is to be off-grid. So there's like a greenhouse built in to the building on this corner, where it's going to have like a large greenhouse where we can put kind of hydroponics inside. There's also in the middle, there's another light well where we're going to have more kind of farming, like a green wall. And then this section here is going to be similar to this veg patch. We're going to have like a lot of kind of a little bit more extra farming here. So we're hoping that we're going to get a huge amount of kind of vegetables and fruit and vegetables all grown up, and we're planting a lot more fruit trees around. So we should be relatively self-sufficient, which is going to be pretty good, even with food. So
nice.
kind of busy.
Yeah, fantastic. Well, I think it's been really great to see everything you're doing, and look forward to hearing more about it, but when it's not under wraps, so we can find out a bit more and have a look around this house when it's done, because
exactly.
it sounds really cool, and I'm looking forward to having a sneak peek at the plans.
Exactly, off camera.
Off camera, exactly. But no, absolute pleasure. Thanks so much for having us. Thanks for showing us everything, showing us around the house, and letting us talk in the wonderful garden. So
good to see you.
Look forward to seeing you again soon.
Yeah, can't wait.
Cheers.
Sorry to interrupt, but this episode is sponsored by Water Offsets. If you are working on projects where you might need environmental credits, then they are the people to go to. They specialise in not only biodiversity net gain credits, but also water neutrality and nutrient neutrality too. So if you have an estate, a farm, or some other kind of landowner, or interested in that kind of project, then they could really help you find, new ways of funding those projects and diversifying your land and farms, to take you through the whole process. And if you're a developer who's run into problems, then actually they can help provide those credits that you need to unlock your land and get your development done. So check out Water Offsets if you need help with any of those things. Many thanks. I hope you enjoyed this episode. If you're interested in finding out more, then why not check out our episode with Edge Urban Design, where we talk all about, urban design and development as well, or our episode with Dougal Driver, where we talk about building with timber. Quite similar to this episode, but more in the sort of high level and detailed side, so it might be of interest. Don't forget to like, subscribe and share, and also share to friends and colleagues who might be interested. A huge thank you to our incredible sponsors, Marshalls, Water Offsets and Vectorworks, our kind supporters, Julian Goodson Design and the Birmingham Botanical Gardens, and of course, NDLA and Monster Don for powering this episode, as well as a big thank you to Will and his parents for letting us film around their fantastic house. Many thanks and see you next time.